Okay, all right. You understand that nighttime is obviously far more comfortable for me, right?
Oh,
So
yeah.
yeah, the problem is I as of now early morning is good, but early morning I think is not going to work for you, right?
Early
No,
morning is fine for me.
early morning normally you have school or something, right?
Yeah. On school days, yeah, but now it's fine.
Now
Yeah.
now I understand, but oh, early morning now you're actually good with early morning.
Yeah, I'm fine.
Till what time are you all right with it?
I have another class at tomorrow, like around. I'm not sure when the class is. He told me, he'll tell me. He said me somewhere before 11 o'clock, so I'm not too sure about that.
All right, okay, all right. Now, where was I? Forget about the classes. Now, your photos. That's why I switched off the phone. Send me your notes.
Yes, sir.
And how were you finding the alkanes? Solving questions from alkanes.
It was okay, not too bad.
And
It was
what type of questions were you struggling with?
struggling with mainly like those like 1 second.
Is this the elementary one or is this the advanced one?
I mean the two levels. I did both. Like
Okay, all right. And all right, so hmm, let's see. So, what kind of questions have you had issues with predominantly?
like like the products which are formed from the reactions. Like mainly the questions are based on that. Like yeah, stuff like that.
Effectively, anything which is meaningfully complicated question.
Ah, and
And how have you addressed that issue?
I asked a few of my friends, and I got it cleared out. Yeah,
Effectively, you have just directly gotten it clear
yeah, yes, sir. I
as
mean,
doubts. All right.
most of
So,
the questions weren't. Yeah.
hmm. All right. So, effectively, can you give me a couple of examples of the questions you ended up having problems with when you say reaction type? Now, be a little bit more specific, please.
1 second.
Hmm.
I mean, not much of a problem, but one example is how many dichloro products, including stereoisomers, will be formed when R2 chloropentane reacts with Cl2 under UV radiation.
Hmm. 2-chloropentane reacts with chlorine in the presence of H nu. And you're going to be having in this particular case here, what exactly did they say? This is R configuration. Huh?
Yes, sir.
They
R2
specifically
chloropentane.
mentioned this is in some particular configuration. How many what
Hmm.
products?
Dichloro products.
Okay. So can you explain how to solve this?
Well, this chlorine can attack any of the hydrogens. Like,
Can we start off with what you need to do first? Let's first number, shall we?
I, yes, yeah.
Hmm. Now tell me, continue please. Where can the chlorine go?
The chlorine can attack any. It can pretty much replace any of the hydrogens. It can go
Hmm.
either at 1, 2, 3, 4, 5. Yes, yeah.
Okay. So let's start off with each place here. What is asked here? Number of dichloro products, distinct dichloro what?
Dichloro.
And
Yes,
have they
sir.
mentioned anything extra? Optically active dichloro, anything of that sort?
Including stereoisomers.
That is total.
Yes, total. Yeah, yeah.
Okay. All right. So let's start off then. So in this particular case, if it is attacking carbon number one, right?
Yes.
Explain to me what are the products formed?
So
How many products are formed?
only one is found.
Why is there only one formed?
Oh, sorry. Give me a second. No, not 1 second. Two are formed. So because once chlorine comes in, then it will be CH2Cl, and then that carbon two is chiral. Then
I think I'll get my video on for a while. I would like to express my disappointment with my face. So, tell me again, please. Yes. Please continue your wonderful logic over there. I'm very much interested in listening to it seriously. Please. So, carbon 1, if the attack is happening, carbon 2 is suddenly going to become extra optically active. Is it correct? This carbon, which was already optically active in the first place,
it won't become.
is
Yeah.
a fixed configuration already.
Yes. Yeah.
What is going to happen to that?
Nothing will happen. It's already fixed.
Yes. So, this guy is going to give me only one
Only
product.
one. Yes.
How about here? If it attacks the second carbon,
There also one.
why one product there?
Because it can only attack that. There's only one hydrogen to attack there.
Okay, so I'm going to break this question down a little bit more. I'm going to ask all the optically active dichloro products as another possibility, and total is going to be another. I want you to mark it out as a point on x-axis and y-axis.
Quadrant axis.
And I'm going to basically make this even more trickier. I'm going to make another part over here. I'm going to ask for trichloro, or say I'm going to change the R to an S. And I'm going to have 2 points. I'm going to ask you the distance between those 2 points. Shit can be done. That's how your max questions are, correct?
Yes, sir.
So just because a couple of other subjects are a lot more creatively they're trying to make questions doesn't mean math doesn't. Math also does that once in a while. But same drudgery can be brought here also. And where if you can't even solve this step and you don't understand this, you're done. So let's proceed on. Is this second compound, if it attacks the second carbon, what is that compound looking like? Is it optically active, optically inactive? Give me more details, please.
It will be optically inactive.
Why?
It has a plane of symmetry. And I mean, first of all, there is no chiral carbon.
Yes, that's the goddamn answer I'm looking for.
I mean that also.
No, don't give me plane of symmetry shit. You're not supposed to look for plane of symmetry in the first place. What's the first thing you're supposed to look for when you're asked for optical symmetry?
Chiral carbon.
Yes. Your brain should not think plane of symmetry. If your brain is thinking plane of symmetry, you're already on the wrong track. That is the reason why you couldn't see in your brain that carbon 2 was already chiral. Because you stopped thinking chiral for a second. You started thinking plane of symmetry. To some extent, that was part of it, yes?
Yes.
All right, so third location. How many products?
Now if the chlorine attacks, it can. Give me a second.
How many products here?
1 second.
First of all, this is where you're going wrong first. Never goddamn think in the goddamn air. Sit and put pen to paper now. This is not other parts of chemistry. This is the part of chemistry which is most similar to mathematics. Put pen to paper. Keep writing, fill in more pages. Especially when you're not able to visualize it properly, put pen to paper. No thoughts over there. The problem here is you have to start understanding your intuition is your problem in most of these questions as of now. Why is your intuition your problem? Because you have not built it up yet. So to build up your intuition, you need to do mindless type of thing. That's why you that's why you liked solving straightforward questions in the same chapter. Because it felt a little bit more mindless and you got grinding done. Right? To an extent, it felt, at least it should have felt a little bit like that.
It did, yeah.
Now, in this here, tell me here, carbon 3, if it is attacking, What will you be getting as a product here? You'll be getting this guy as a product,
Yes.
where I'll have this and this here, and this is fixed in R.
Fixed. So it's not really optically active.
Yes, but this carbon,
This up and down.
don't say that. Don't say that first. First
It's
of all,
not
don't call it as it's not
chiral.
really optically active. That is bad mistake
No,
there.
it's not chiral. What is it?
It is chiral.
I mean the first. Okay.
It is chiral. It is
But
just
fixed.
fixed configuration where without anything else attacking at that location, it is not going to be changing. It is fixed. That's all.
Huh.
Nothing else. Nothing else.
So-
Don't add any extra information. That's what I was trying to say there. Don't add any extra information unnecessarily. So in this case here, this guy is also optically active now. Correct. So this can be either in R or S. That
RLS.
means I get
Up or down.
RR and RS.
Yes. Correct. Yeah.
What are the products obtained here?
Two are there.
What are they? What is the relationship between them?
Oh, 1 second. RRRS diastereomers.
Good. So we get a pair of diastereomers here. Fair enough?
Yes, sir.
Now, draw the same thing for fourth fellow there yourself and try and tell me what you get.
Yeah, and again, pair of diastereomers.
Good. In
Oh,
this
no,
case,
no.
what is critically interesting here?
It's symmetric.
Which one? One of them. We don't know which one though. Correct?
Yes.
Do not
1
assume it
second.
is the RR. Do not assume it is the RS.
Wait, we can find it, no?
You can find it, but I'm saying do not assume.
Okay.
And do not waste your time finding. It doesn't make a difference. One of them is optically inactive. So you're going to be
Yes.
having one optically active,
Meso.
other is meso.
Yes.
But both are applicable. So you end up getting two here, two here. And we got one here.
One in each of them. Yeah.
And how about in the 5 here?
This one, only one.
Only one. Good. So effectively, these are going to be your products over here.
Yes, sir.
Properly clear now?
Yes, sir.
Now, if we are to basically have this kind of a reaction happening, this is basically actually not that complicated a question. Now, let's go for some other question here. Any other more complicated questions which you had problems in this topic? Anything else which you struggled on normally, which you felt was tricky?
Nothing really. Nothing other than this.
Then you probably did not solve good enough questions then.
Yeah, I don't think I did.
Did you solve questions involving halogenation with respect to percentage yield of product, etc.?
Yes, I've done that. Yeah.
And did you solve questions related to halogenation, percentage yield with isomerism, with this type of thing added in? For instance,
With
in this
this-
question here, if I'm asking you, if I'm giving you in this question, let's say I'm adding you one more piece of information. What is the ratio for 1 degree is to 2 degree is to 3 degree chlorination attack?
1:3.8:5.
Beautiful. So in this here, I can make this question a little bit more complicated. I can ask you, what is the percentage yield approximate of each? You understand the idea here, right?
Yes,
How
sir, yeah.
the same thing can be extended. How would you
Yeah.
proceed in that particular case?
You can first find the relative amount of each of them.
So let me start off with one of them. Let me take two as a comparison and give me for ratio for the two of them. Which ones do you want to pick here?
Carbon 3 and carbon 4.
Fair enough. Okay, go for carbon 3 and carbon 4. They are both going to be same amounts.
Yeah. Yeah.
Why are they going to be same amounts here?
Because of the same number of hydrogens attached. Like it can attack either side. And
So now
they're
I'm
both
going to ask you a more
secondary.
complicated question here. What is the ratio of the products obtained between carbon 3 and carbon 4? If I'm going to be having products over here, say, let's call it as product from carbon 3 attack and product from carbon 4 attack. Is this ratio greater than 1 or equal to 1 or less than 1? What do you think it should be? You understand the
should
point of the question over here, right?
Yes, sir. Yeah.
I'm taking the product from the location 3, both products, and products from location 4, both products.
Yeah.
I'm going to look at the total amounts of both obtained. I'm going to take a ratio. Which is going to be greater and why? If they are greater. If it is not greater, if they are both exactly equal, why? Now, let's go to this ratio.
think
You have an answer for me?
I think so, but I don't know the reason
Please tell
exactly.
me. No, don't worry. Don't worry about the reasons right now. Let's see how your instinct is.
I think product 3 because the other
Product
two
3
will
is
come
greater or lesser? What is the answer here?
greater than 1.
Product 3 is going to be greater than
The product of
product 4. So that means product 3 by product 4 is going to be greater than 1. Is that correct?
Yes. Yeah.
Good. This has been a very wonderful example to show exactly how fucked up your instinct is. All right, so let me go back to the point over here. Let's take this. How did this ratio come?
Experimental.
How was this ratio theoretically understood? Now, this is where things get interesting.
Chlorine would.
Yes, tell me.
I'm not too sure, but think if chlorine is about to attack the third degree hydrogen.
Calm down. Calm down. Take a deep breath. Take a deep breath. Close your eyes. Take a deep breath and release it peacefully. Make sure your exhale is much longer than your inhale. Do this once or twice more. Now, do not get defensive. Stop being defensive. I want to put you in a corner. Why? I want to see how your instincts are with respect to the subject right now. Because my gut feeling is telling me your instincts are not well developed for the topic now. And I need to make sure your instinct understands that so that it doesn't ever rear its head. Because your instincts are not built at all right now. So, in this case here, this has nothing for you to get defensive about. I just want to show you what are the pieces which you need to start connecting from now on. And this is the first place where I'm going to be showing this to you in the first place. This is the first reaction, literally. So relax. You're not expected to know the pieces by yourself. And your teacher has not had time to patiently explain shit. He has not shown you the pieces which need to be connected. First of all, this reaction. Let's start off with
I think I have an answer.
Tell me now.
If the not sure if the plus charge is formed on a third degree carbon, it's more stabilized or something like that, maybe.
Again, what is your brain trying to do now?
Make up some reason.
No. It knows the answer now has to be the opposite. So it is trying to find excuses to basically fit the picture in. It knows the mold which it has to follow now. So it is forcing your information into the mold. And in doing so, it is making a blunder again. The blunder being, you're assuming it's a goddamn carbocation.
Yeah. That was my own problem. I'm not sure if that's.
You understand what I'm trying to explain to you here? Your instincts are dead wrong here. Your gut feeling as to what to do, that is correct.
Carbon free radical.
Yes, all of that is fine now because I have eliminated your options out, my friend. Stop praising yourself. This is not your brain doing this shit here. Stop praising yourself. Stop feeling good about it. What did you do just now? I gave you clear-cut information ruling out options. You can do this tomfoolery with someone who is not on par with you to see what is happening in your brain there. I can clearly see what your brain is doing here to me. Don't make excuses up. You are not able to see the connections at all. All you see are connections everywhere. You don't know what is the correct connection. You're not able to sense what is the correct connection in any way. All you see are connections everywhere. But the connections are there everywhere. Your job is to hone your instinct to move towards the correct connection. In this case here, how to recognize what connections to watch for. That is where the synopsis comes in handy. Your synopsis should not be fucking notes. For this reaction for halogenation, your synopsis should be 4 lines. Absolutely not more than 4 lines. And it should contain all of the information which you need to solve any sort of question. For instance, in this case here, what was the details you were lacking? Halogenation. The moment you hear the word halogenation, your brain should go, it's a free radical mechanism. Now, free radical mechanism. Now, what does that tell you? That tells you stability of free radical.
Has something to do with it.
Is the most important thing to pay attention to. Now, what type of species is a free radical? Is it electron rich or electron deficient?
Deficient.
Deficient. So this is electron deficient. So if this is an electron deficient species, what type of effect will it like? Something which donates electrons to it?
Donates. Yes.
So what type of effect will it like?
Plus I. Plus M plus R.
Whatever you want to call it. Right. So these are the 2 effects it will prefer. What will be bad for it?
Minus.
Now, look at this compound here. Your brain told you this third is in the center. So best. Why? Because your blind assumption is this thing is going to be something where it is similar to carbocation, carbon free radical. Your brain automatically said middle, more crowded, best. Something of that sort?
No.
Oh no, you had no thought there. Okay. My mistake there. Sorry. I can see you did not go this step at all. Now I can see that. You never went this far at all. Your thought process never went this far. Okay. My mistake.
Yeah.
Sometimes kids also go down the path and then screw up also. Now the thing here is this chlorine here is a minus I group.
Yes.
So that is why the 3 is going to be not that good as 4.
Understood. Yes. Okay.
So understand the point here. So even though you expect them both to be 3.8, one will not be 3.8. One will be less than 3.8. The other will be slightly more than 3.8. Not necessarily more actually, because for this also the chlorine is minus I only. So both will be less than 3.8. But the 3 will be much less than 3.8 compared to the
delta minus.
Yes.
Plus.
So that is the thing which you have to start connecting here. So in this case here, to connect the pieces, what did you need as information? To understand the entire crux of this question, what did you need as information for halogenation?
Free radical.
Correct. All you needed to know in this entire thing is it follows free radical mechanism. And the moment you say free radical, the other thing should connect. That is free radical now. It is electron deficient. It should already be there in your brain connected with free radicals.
Yes. Okay.
If that has been populated with free radicals in your brain already, And once you know that electron deficient, that should automatically be populated with, oh, plus I plus R good for this, minus I minus R bad for this. If those connections are present and kept in your brain before you reach here, then you will be able to synchronize it relatively peacefully. That is the job. And once you have connected it, then you should recognize, okay, the reason why this stupid order is like this is because of the free radical part here. Now I have another question. If it is bromination, what is the order?
1 is to 82 is to 1600.
Somewhere around 1 is to 80 is to 1600, correct?
Yes.
Why is the order this way for bromine? Why is the other way for chlorine? Why is it like this? What is happening here? What does this tell you? What is the difference between the two of them? This is something which I'm 100% sure your teacher would have mentioned in your class at least once or twice, because this is quite commonly asked.
Yeah.
What was the excuse which sir gave you? You being a very smart, intellectual kid will be able to remember more or less close to verbatim what he would have told you. Tell me. That is your best suit, right? Go on. Let's see how your ego catches your checks.
So ego is something.
Something related to
size. I mean, obviously size, but then chart disparity.
Don't feel bad. I know I'm trying to put you on the spot, but that's for a reason. People like you and me work better when we are put on the goddamn spot. The two answers you gave me just now are actually more correct.
Charge disparity.
No, I'm not going to explain why it is more correct. That is up to you to think. Don't come up with random shit to connect them for the sake of connecting them now. So tell me, what is the reason why? What is happening here? What do you see here? If I'm looking for fluorine, what should be the order?
1 1 1.
Dude, really?
I think lesser. That's what they.
You're giving lesser, but don't call it 1 1 1. What the fuck, really?
That's what you were given.
It is not 1 1 1. What nonsense?
Yeah.
It's not 1 1 1.
That's what I was. Yeah.
It is going to be closer to 1 1 1. It will be like 1.1, 1.15 or 1.2, some nonsense of this sort.
Something like that, yeah.
It will be still in this increasing order only. That is not going to be changing. Okay, there will be a difference, but the difference is going to be more subtle.
Yes, sir.
Now, what is it telling you? So if I'm asking you, what is really happening here? What is the best way to imagine? The best way to imagine is like this. I've told you in chemistry, what is the ideal thing there is visualization.
Yes.
So in this case here, the ideal way to visualize is like this. First off, who is the person who is going to be starting the reaction in the entire process here?
The halogen.
Good. So in this case here, that's why the sunlight or light or whatever shit is there. The light, or in the case of fluorine, nothing is required.
To break it into free radicals.
Good. It will break into free radicals in the first step, and that guy is going to go and perform an attack. So the attack is happening because the halogen atom is highly unstable and wants to go do the attack, correct?
Yes.
So now I am having a buffet available in front of me.
Oh, okay. I think I know it. Okay, yeah.
I have beggars in front of me now. Different types of beggars at different levels of starvation. So in the buffet here, it's a very interesting type of rule which is allowed here. I mean, it's not about a rule even. Buffet is basically food over here. So the point over here is when you're going to be having different types of food, the person who is going to be starving most doesn't give a shit if it is curd rice or if it is the most exquisite Afghani kebab or what to say, the most exquisite paneer malai, whatever nonsense. Yeah. So the idea here is when you are going to be having a very highly desperate species, highly unstable, highly disparate species that is not going to be giving a shit about selectivity.
Fluorine.
Now, as you go bigger in size, what happens is it is going to be something which is going to be having more and more stability.
Yes.
And as it is going to become bigger and bigger in size, it is going to have greater and greater stability. And that means that fellow is now less reactive. It is more choosy now. It is, yes, a beggar, but it is me or you being a beggar. And we are not going to be going and eating food from garbage even if we become a beggar, my friend. We will wait for the restaurant to close where we know that fellow will give us food. And we will make sure we have proper puppy dog faces. So the idea here is there is going to be differences in terms of preferences. Mainly because there is a difference in the stability of the species itself. In this case here, the chlorine is going to be far more stable as a chlorine atom compared to fluorine atom. Hence, the chlorine atom is a little bit more picky compared to the fluorine. But the bromine atom is far more stable compared to a chlorine atom. So it is enormously more picky compared to the chlorine atom.
Yeah. Makes sense.
That is the idea in this case here. When you're going to be having any reaction happening, the purpose of learning mechanism is to understand the core principles behind what is happening in that reaction. If you understand the core principles clearly, all you need is 1 or 2 pieces of information, maximum 3 or 4, to basically connect all the pieces necessary and straight away be ready to solve questions of any level of complexity. How many lines of data do you have for your halogenation in your synopsis?
There's a lot, sir.
There's at least 1.5 pages.
Half page. Yeah.
Half a page. You have to cut that info down. You would have put all kinds of nonsense about this is this type of. What all have you put? Just show it to me on the thing. I'll just see it on my phone.
Just a second. I didn't send it yet.
No, just show it to me on this thing. But that is easier, no?
Sir, what?
Show it to me on this thing. I'll see it on this thing itself.
I don't think it'll be visible.
Oh, it'll not be visible in the real.
It's pretty small. I sent it, sir. Yeah. I sent it already.
You sent it?
Yeah.
Perfect. Let me have a look. You've written too much, Ravana.
Sir? Huh?
You've written so much. Okay, in this year, halogenation is very small actually. It is
No,
not
there's more. Next
yeah,
page.
it's quite relatively small. It is not that bad. But it has no meaningful information. It has all types of shit there. Well, it is not half a. Oh, when you said half a. This is not
This
half.
is more than half.
Dude, this is not half a page. You wrote for a full page. Or
No,
nearly a full page. Other side is also full.
Other side is something else. It's not halogenation.
Other side is half that page.
Yeah. It's pretty bad.
It's not about it's pretty bad, Rab. It is about the fact that you basically copied your class notes and synopsified it. You didn't care to think what you understood over there. The idea of writing a synopsis is you are not supposed to, put down everything there. You're supposed to be as concise as you can be. Because the more concise you are, the more, precise you are as well. Because the precision part of it here is going to be the key thing. Because every goddamn book can give you shit ton of data, man. That is not going to be really doing much over here. The data which you're having is not really going to be the meaningful thing there. It is about whether the data is something which you can make use of to the best extent as possible. Because if you cannot make use of the data, did I ask you any question outside of the data?
No.
Now, were you able to solve the questions which I just asked you about over here?
Yes, sir.
You were able to solve these by yourself now?
I mean, no, not by myself, but
No, you definitely were not able to solve them definitely here. So the point which I'm trying to make here is the information should be something which will direct you towards the correct thought process. Adding in extra information because it might help you solve one or two more questions is not the ideal here. In this case here, make sure the information which you're going to be adding here, what type of information should it be? Let's look at halogenation here and put down a synopsis entry for it first. What would you put down in the synopsis entry now? Ideally.
halogenation, free radical, like aroma, free radical.
Okay. So halogenation, we'll be having free radical mech. Okay. Next.
And then
Hmm.
the relative, the
I will need to
relative
mention
reactivity.
halogen atom starts attack. If I'm mentioning this, then I don't need to remember the stupid mechanism.
Yes,
Correct?
yes. The order you don't need to remember.
Yes or no?
Yes, sir.
That is how you need to condense information. Your job is to see what is the crux point in your brain for that data which has been given. And only put that down.
So
Halogen
rather than
yes.
so this halogen starts attack implies that like again all this stability bromine is larger, so
Good,
it'll have
good,
lesser.
good. Halogen atom starts attack implies what? Implies halogen atom
Which is less stable.
decides selectivity.
No, rather than this, why can't
To
you just
product
put the
formation and location of attack. Correct?
Yeah.
Another thing which you can learn from here about halogen atom starts attack. What else does it give you?
Sunlight.
Speed of attack.
Oh.
Right? If the halogen atom is bromine,
Yeah.
is it stable or not stable, or is it how is it compared to the fluorine and
Stable.
chlorine? Stable. Which means this fellow will be attacking faster or with much more difficulty.
Difficulty. It's very
Exactly.
stable.
So you need to pick pieces of information which can act like markers for you to connect your thing to more pieces.
Yes, sir. Yeah.
Now, in this next part here, I will not put these two, by the way. That is, these two parts I will not mention.
Yes.
I don't need to mention. But in the first round of, preparing a synopsis, mention them. It's okay. Even if you mention them, you're not going to be going beyond the 4 lines. Mention them in a meaningful manner where it is not going to be taking too much space.
Yes.
Don't add unnecessary extra information. Add only information which you cannot link up and which you need as information.
Okay.
You
Yes.
understand? For instance, this data is superfluous. But from this data, you get 2 more. Chlorine ke liye, you'll be having 1 degree is to 2 degree is to 3 degree, that ratio. Can you neglect that ratio?
No.
No. You need to memorize that stupid ratio because they ask you stupid questions on that. Correct?
Yes. Yes.
So you need to memorize this ratio here. There is no escape for this.
So then, rather than writing the entire text, we can just put this and then we can derive that from this. Right?
That's the point I'm trying to make here. You have to do it like that only. You're not supposed to put that text over there. This text part is not really required. That text can be directly replaced with this if this connection is automatically made in your brain.
Yeah, that's not. Yeah, okay.
And the next piece of the puzzle there is going to be, well, any other pieces left over? You tell me.
Relative amount, maybe.
That gets taken care of here. How do you mention? How do you mention that relative amount? Halogen atom starts attack and attacks hydrogen atom.
Identical.
Attacks a hydrogen atom.
Yes.
So
Yeah.
what does that tell you? That is also connected to this only, no?
Yeah.
So it attacks a hydrogen atom. That means the number of hydrogen atoms
Also play effect in
also play a role.
Yeah.
So the key piece of information which is going to be meaningful here is this. Correct? If I add that into this gets automatic. Yes or
Okay.
no?
Yeah. Yes, sir.
So if I want to remove this, I can remove this now. And if I want to remove this, I can remove this now.
Yes.
So in this particular case here, this much information currently now gives you more than sufficient information to go and
Yes.
crack most of the questions.
Yeah.
Now, is this complete? You tell me, what other types of questions have you seen? You have seen 100 questions at least in this chapter now.
Yeah.
So tell me, there should be other questions you have seen about this.
Yes.
What other pieces have you seen? You must have seen pieces where they talk about how optical activity can happen.
That's yes.
Is there any information here about that?
About that.
There is no information here about
No,
that. Correct?
no, it's not. Yeah.
So there is information actually, but it is hidden. Where is it hidden?
Wait.
It is hidden here.
Free radical.
Yes. If it's a free radical met, that means a carbon free radical is formed at some point of time.
Yes.
Right?
Oh.
Carbon free radical means, what is that guy? Shape wise.
Oh.
Planar or
Yes.
planar plus tetra. Basically, it keeps changing shape, correct?
Yes, yeah, correct.
That's what I'm sure your teacher would have mentioned this in your class for sure.
Yes,
Or if he's not mentioned it, the idea there is when you're having free radicals which are going to be present without too much steric hindrance. Do you know what steric hindrance means now?
Yes, sir.
So when there is not that much steric hindrance, those free radicals can change from tetra to planar whenever they wish like. And they generally can go in all of those shapes. The ones which are going to be very fat, they will try to, remain in tetra type of shape. So depending on the situation, actually, it depends on what type of a scenario they are in. So if it's very fat groups, then it will go for tetra predominantly. But if it is thin fellows, it might go for the planar itself. So in this particular case here, the key data there is the carbon free radical is formed, which means it is going to be something which will give both possibilities. Why? Because it is something which is usually planar in nature. If it's planar in nature, what's the advantage of something being planar in nature? You're still not working. So what's the advantage of something being planar in nature? Give me a second. Let me put up my video again.
Yes, sir.
So the piece of information which you should be taking from the planarity part here is like this. In this particular case here, when something is planar, it can be attacked by the species which comes and attacks it either from the top or from the bottom.
Either side. Yes.
Which means at that location, it will give you both possibilities.
Understood. Yes.
You understand the principle here? So if it's a carbon free radical or a carbocation, which is being formed, because carbocation is also usually almost always planar. So when you have a carbon free radical or a carbocation which is going to be formed and that location is getting targeted, you will be automatically getting both possible optical systems.
Yes, yeah.
That is the key piece of data which you should automatically connect with the moment you see carbon free radical or carbon carbocation type of system.
Yes. Yeah.
Now, in the beginning here, you do not have enough data in your brain. So you are going to find all of this very, very complicated because you will have to write it down properly. I'll give you an example here. The best way of how to say making your synopsis here would be like this. Think of it as you are teaching your younger self. All right, this topic. But you need to make sure your younger self does not get scared of this thing. But you want to make sure your younger self or your
prepared
past self is able to answer some questions at least in these shitty exams.
Yeah.
So what would you put there? You know, every teacher is going to give all the junk anyway. So what you need over here is the key pieces of connections which are not going to make you feel burdened. The moment you feel burdened in your brain, that one equation is a goddamn half a page plus to memorize, you will never goddamn memorize it properly. And the moment you are not memorizing, you will not be able to make the connections. Your instinct is not getting trained. For your instinct to get trained, it needs to memorize just the correct amount of data. If it overeats, it doesn't make the correct connections because it doesn't understand what needs to be connected because there's too many connections again.
Yes. Yeah.
So consciously, you have to train it to accept these connections. So please start writing your synopsis more carefully. I'll give you an example here. This is going to be something which your father is in the IT industry.
Yes, sir.
So then he might understand this better. When you're in an IT industry, right? When you want to basically pitch for a project or something, or when you're having a big meeting, a big brainstorming session, Amazon usually does this actually. Amazon, what they do is they have like a meeting where every meeting starts with a half an hour of quiet time, where one person in the meeting would have prepared a set of notes, a 6-page set of notes. Maximum it has to be 6 pages, which are detailing that person's understanding of what the meeting is supposed to be about. The ideas which are supposed to be discussed. Then they will sit and read it on the spot and then they will discuss. Every one of them will read it for half an hour. This is only something which will happen for like middle and high level meetings. So seeing that you are not really badly off, your father should definitely understand this. So usually higher level meetings generally end up happening in that fashion. You are expected to prepare for other people a set of notes which will not make them feel put off by your notes. But it is also giving them good amount of information for them to understand and help you in making your ideas better.
Understood. Yes.
So the goal now is to make sure you are preparing for your past self or your future self. Keep that person in mind as the customer. That person should not be turned away by this. That person should feel at the end of the day, arre wah, all I had to study for this entire chapter to revise it to a reasonably thorough extent was just this much. And now I'm confident that I can answer 75 to 80% of questions in this chapter comfortably. What you have done in your synopsis now is you have aimed for 100%. That's the mistake. Aiming for 100% is very bad. Why? Because aiming for 100% in the beginning now is not feasible. Not when you are just walking or when you have just started walking or when you have just barely started walking. You're not crawling anymore since you have done 100, 120 questions in this chapter. I will give you that you're not crawling in this chapter at least, but you're definitely not yet comfortably walking. You're walking in a very crab-legged way right now. So you can't go into a running race and expect that you'll win a marathon over here. So you have to prepare in that angle here. Okay, now next. So you understand the kind of details you require over here, and any other piece of information you will require for this now. One line you can write an equation, correct?
Yeah.
When you're writing that equation, make sure you're using some kind of a color type of coding or something of that sort to mark that the hydrogen is going to HCl or HX. So just mark off the things cleanly. And more critically, one more piece of information is actually missing here. What is a piece of information missing? The conditions needed for the reactions to happen for the different halogens.
Sunlight.
Yes, for different halogens, different conditions.
Oh,
so that means you didn't know.
no, I didn't.
So fluorine does not require light. No light needed. Because even ambient temperature will get the job done for fluorine. So if you want to limit the extent of fluorination, you decrease temperature drastically. Chlorine, you require sunlight. Bromine, even light is not enough, you need heat. Iodine, the reaction requires an oxidizing agent usually. Without an oxidizing agent, it generally does not get the job done. So you need complicated circumstances for each of them. Why do you need this kind of a complicated circumstance?
Good common questions.
Why do I need nothing for fluorine?
Oh, because it'll readily dissociate into, but
It does readily dissociate, but
easier than.
But there is one more question which will come into the play here, correct? Which is going to be bond enthalpies of each of those halogens.
Yes.
Technically,
There's some finite
bond breaking.
Yes.
Now I can tell you this. Fluorine is easier to break than chlorine. But that doesn't mean bromine is not easy to break. Bromine is easy to break also. Why is it that these are the necessary conditions here? It is not just because of the breaking. The breaking is also easier for fluorine, but the product formed is also far more stable for fluorine.
Oh, okay, I see.
The idea here is this is something which involves another chapter which they have not covered for you kids yet. It is very frustrating. So the idea here is stability of the compounds over here also starts mattering a lot. The carbon-fluorine bond is one of the strongest of the carbon bonds possible. Okay. So the product formed, you're familiar with ozone hole?
No.
Really?
I mean, I know it is.
Tell me then.
I mean, I don't. I mean, I just heard of it. I'm not too sure.
I did hear. I know it. So I want to know what you know about it. Tell me.
I heard of it a few times.
Go on. It's okay. Whatever you know, whatever your brain tells you, you remember. Tell me about it.
Hole in the ozone layer.
And what is causing it?
Like this carbon monoxide.
Carbon
monoxide.
No.
Oh, CFCs. Oh, yeah, CFCs. Yes.
What does a CFC stand for?
I don't remember this, but
think what should stand for in the context.
Fluorocarbons. Fluorocarbons.
Beautiful.
Oh, I guess.
Yes, that's what I was telling you in the current context. Use your brain and guess. Your brain is not that bad. When it is pointed in the correct direction, it is good. There's no problems about that. I'm not saying your instinct is bad at all. Your instinct is generally good. The problem here is your instinct is not honed right now. It's like you got claws, but you don't know that you should not point the claws at your face. If you point them at your face, you might gouge your eyes out.
Yeah.
Now, chlorofluorocarbons. Why is it that these guys cause a hole in the ozone layer?
They react with ozone.
That is true. But why do other things not react with ozone? You understand my question there or not?
Yes, sir, I understand.
Why is it this guy specifically?
Because the product form is stable.
Yes, actually, the idea here is our atmosphere is
Yeah,
something which
to
is going to be getting a bath of radiation continuously
hmm.
from this thing called the sun.
Yeah.
Okay, so the kind of energy which goes in breaks down most bonds, excepting the ones which are extremely stable and extremely strong. So what happens is pretty much all the substances which can react with ozone are already destroyed before they can reach the ozone. You understand the issue there?
Yes, sir.
So anything which can react with the ozone and destroy the ozone is already destroyed by the inherent radiation from the sun.
Except for these TXGs.
Except for these fuckers who are extremely stable bonds. So they have extremely stable bonds. What are the extremely stable bonds here?
CF. Okay.
Not CCl, CF.
Hmm.
You don't hear of chloroform going and causing the ozone hole, correct?
Yeah.
You heard chlorofluorocarbons. Chloroform does nothing.
Sir,
It's
why
you to
is chloro
sleep,
there then?
and it also can produce phosgene, which is highly poisonous. But yeah,
That
you
cannot.
asked something just now, right?
Why only chlorofluorocarbons when not bromofluoro? Like,
See, it is not just chlorofluorocarbons actually. It is fluoro compounds, basically.
that makes sense. Okay, yeah.
This is the essence. Now, the chloro is because most of the time when you're going to be having compounds of fluorine, they usually end up having chlorine compounds, chlorine atoms present along with it when they are used in the form of aerosols. All right, this is the kind of compound which is generally present as a gas. If it is only a chlorine and carbon and a fluorine compound, it generally ends up becoming something which becomes a polymer, like your Teflon type of shit.
Okay.
So that is not really going to be that much of a problem. That is a problem in other places, but not in ozone nonsense there at least. So in this case here, why not bromofluoro? Main reason is because the chlorofluorola, the chlorocarbon bond over there is also more stable now because of the fluorine being present. In the bromine case there, the carbon-bromine bond is very shitty. That is the reason why this needs heating. Carbon-bromine bond is very weak. The only thing weaker than that is a carbon-iodine bond. Why? Because the carbon is in the second period. Where is bromine?
Third period. Fourth period, my bad.
You don't need to say like that. It's just rusty. You're not wrong there.
Yeah.
So now in this particular case here, this is going to be, do you want me to give you an example for this bond or you can imagine?
No, I got it. It's fine.
You can imagine. Wonderful.
Yeah.
So I have a very bad example in my brain, but I could see your dad or your grandfather walking. Your dad or your grandfather?
Grandfather.
Grandpa. So somebody was walking around. I do not want to make them feel unnecessarily embarrassed more than they should. Which should give you an indication as to which angle I'm going with the example there. Now, the point here is this bond is highly unstable. Why? Because one is extremely tiny, other is extremely big.
Yeah.
You are never going to be having any type of bond which is going to be even reasonably stable there. Chlorine, on the other hand, is just about acceptable enough. If it was bromine, it would have already destroyed itself before it even reached the ozone layer. Now, coming to this particular part here. So the ozone hole is basically caused because of this chlorofluoro thingy, because the fluorine carbon bond is being something is very stable there. Now, coming back to the next piece of data here. The reason why this fluorine reaction happens that fast and the bromine and iodine reaction require that extreme conditions is because the products formed are highly unstable for the bromine and iodine. And the reactants are more stable.
So you'll have to provide more energy.
Exactly. Meaning if you look at this here, these are actually endothermic reactions. Endothermic.
Chlorine also?
Do you know what that means?
Yes, sir.
What does it mean?
It needs energy to
It absorbs energy. So it needs heat.
yes.
These two guys, on the other hand, produce amount of heat. Tremendous amount of heat, actually.
Cl2 is also exothermic.
Yes. Fluorine is exothermic. Chlorine is exothermic.
Chlorine. Okay.
Fluorine and chlorine, both are exothermic. Overall exothermic. When you are looking at the complete product formation, not fluorine bond breaking.
That'll definitely be.
Don't think of it as fluorine bond breaking. No, that is obviously going to require energy.
Yes, exactly. That's right.
So all the bond breaking will require energy, but the bond forming will release also. Correct? So the net put together is going to be something which will be resulting in a far more stable product for fluorine and chlorine, making them exothermic. Whereas for bromine and iodine, they are going to be less stable than the original reactants, making them endothermic in this case. Now, this was for this year. Let's move on to the next one here. So alkanes, what are the reactions? I saw that you had sent me the thing. Now, let me have a look from that directly. I can see that in your set of reactions of preparations of alkenes, your teacher has discussed Wolff-Kishner reduction, has discussed Clemenson's reduction, and all kinds of extra stuff.
Yeah.
He's not wrong. Let's quickly talk about each of them. So go into Wolff-Kishner. Let me copy that off, I suppose. Let's quickly discuss the Wolff-Kishner and Clemenson's at least. So this is your synopsis for your alkanes, huh?
Yeah, I mean, there's more, but should I send the rest?
Send me the rest.
1 second.
Send me the rest of alkanes.
Previous.
Okay, so he's talked about Clemenson's also over here, I see. And he has been unnecessarily specific enough even to give these cases.
I sent the ones before it. And then...
Yeah. So it's 5 pages totally for you.
Oh, no, there's more.
Huh?
There's more, sir.
There's more. Wonderful. Wonderful. So from alkanes and alkenes and alkynes, from alkenes and alkynes, the Sabatier sentence, what is the key point there?
Sabatier. 1 second. The...
How do you write a synopsis for that one?
Hydrogen will attack. Hydrogen bond initiates reaction where attacks double bond.
No. You're copying what I gave. Stop copying. Stop copying. Go with what your gut feeling tells you. You've seen enough examples of that now, right?
Yeah.
At this time, your gut should be, or your instinct should be a little bit more better than what it has been for organic, at least with respect to this reaction, right?
Yes, sir. Yeah.
So go. You put a whole bunch of data there, compress it and tell me what would you do here.
Hydrogen under the presence of a catalyst, nickel, palladium, platinum, reacts with a saturated compound, and the hydrogen will attack.
Let's just call it as ene plus hydrogen gives N.
Yeah.
Now,
So this hydrogen goes and
How should you stop? How should you, what is the best way to represent this? You can think of it as pi bond and sigma bond are broken.
yes,
And you're going to be
sigma
having
bond is
two
created.
carbon H sigma formed.
Yes,
Fair enough?
yes, sir.
So what will this information tell you?
Bond breaking and energies. It, uh,
Released, because you're breaking
released.
one pi bond and one sigma and you're forming two sigma, which
Exactly.
is more stable.
Breaking. Sorry.
Sigmas are more stable than pi, correct?
Yes, 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 yes.
So effectively, the more stable bonds are being formed over here. That means the product formed is more stable.
Yes.
So this is where the other piece of data which you should have learned from thermo actually will come into play better here. Let me give that to you separately here now so that you will remember it cleanly. If products are more stable,
And reaction will happen.
no, stop
Oh.
extrapolating. Let me give you the point. If products are more stable implies reaction is exothermic.
Okay.
Okay, yeah. If
Yes, sir.
reactants are more stable, implies reaction is endothermic.
Okay.
Okay, yeah. But reaction does not happen only because of stability. There will always be two parts for any reaction to happen. One will be stability. What is the other thing? What is that you are doing now? You are attending classes, you are attending all of this, you are correct? For the
Yes,
sake
sir.
of the future being more stable.
Yeah.
What is the price you are paying?
Freedom.
Correct. So any reaction, there will always be two sides to check. Stability and freedom. Anything, any change, you'll always have two things to check, stability and freedom. So don't assume only one of them is going to be the key thing there. Of course, if stability is going to be something which is going to be better, that helps. Certainly it helps. If stability of products is better, it helps. In fact, you think and tell me, what will be the ideal case when the reaction will absolutely happen? What is your win-win situation?
Product is very stable and gaining freedom and you're also gaining stability.
Yes, exactly. That is the best case, right?
Yeah.
So if you can get IIT without doing anything, best ideal case,
Yeah.
correct?
Yes.
So that is something which will happen like this without any problems. Type of a change you can say will happen for sure. So any change or a process where the system is gaining in both stability and in terms of freedom by performing the change, it will absolutely happen. That change will absolutely happen. So that is the change which will definitely happen. Not something which is only gaining stability. If it is gaining stability, sometimes it might lose freedom.
Yeah.
So in this particular case, have a look here. Is freedom lost or is freedom gained in the process? Stability is gained by products, correct?
Yes, sir.
Absolutely, the products are gaining in stability. So exothermic, that part we have concluded now automatically. Okay, now what else is going to be the case here? What else can you conclude from here? You can technically look at the reaction and say that two substances have combined and become one.
Yes.
So what was originally two pieces which had freedoms individually are now one.
Losing more freedom.
Yes, that means they have lost some amount of freedom in the process for sure. Now that let's negate that. Let's not bother with that part. No, that will go into thermodynamics too much. Let's not touch that right now. Let's come back to the other things here, which you can understand here. So in this case here, you can see that you're going to be having a pi bond being broken and a sigma bond being broken, correct? Huh?
Yeah.
So which bond is more tougher to break?
Sigma bond.
Correct. That means the catalyst is helping which bond break here?
H2.
H2. So the catalyst is acting on the H2.
Yes.
Okay. Now, next, what other pieces of information are going to be useful for you here?
It is cis addition.
Syn attack or cis attack,
Yes.
which basically translates as same side attack.
Same side. Yes. Yeah.
By, you can mention over here hydrogen atoms.
Yeah. That is. Yeah.
From surface of catalyst.
That layer thing. Yeah.
That will basically end up covering a large amount of data which you need to cover off from that. Now, anything else which will help you in the process here?
Maybe something
Get
about
all of the data which you had over there. Let's have a look
this
at it now.
optically active, maybe something.
Let us have a look at the data you have put in. Oh, you have sent me a whole bunch of pages.
Yes. I'll tell you which page. Yeah, there. Yeah.
So now,
Hmm.
do you really need that optical activity crap and all? Isn't that
Not
the
really.
purpose of having the Syn attack mentioned there?
Yeah.
Why do you need all that bullshit there then? I don't see the most important piece of information though here. That is a shock here. I see all kinds of junk here, but I don't see the more critical information which is necessary here. What is the necessary piece of information which is supposed to be there? Tell me. You mentioned the process as ene and ein.
Yes.
But I didn't see ein anywhere.
Oh, yeah.
I didn't see any mention of how it happens for ein there. So for ein, I'll be having same type of hydrogen here, 2 moles of hydrogen.
First happens with conversion.
Technically, in this process here, it is always best to mention how to stop it at ene stage. I'm sure your teacher will discuss that also here.
Yes. Yeah.
So that would have been a more useful piece of information over here. So you can mention ein plus hydrogen in the presence of nickel or palladium or platinum. Directly gives you N. And we're going to be having 2 pi bonds, 2 sigma bonds, and 4 sigma bonds over here. Now, you can add this piece of data here, which will be useful here, which is that when you poison the palladium,
yes,
you end up having the reaction
only
stop.
Yes, yeah.
So you can mention this part here. This would be extra information, which is not going to be necessarily irrelevant here, but could add value to your synopsis part here. But I don't see that piece of data here. But I see a lot of unnecessary junk. All of this junk here, you have no need for it. You have no need for it. Optical activity, obviously you'll have optical activity happening whenever there's a chiral carbon happening, right?
Yeah. Yes.
Why do you give a crap about that beyond a point? Does that matter here? No. Another piece of data which is immaterial here. Optical activity. Why I'm saying optical activity does not matter here? You think and tell me?
Syn addition.
That is not the problem here. The attack is happening on an ene or an ein. That means it's a planar species.
Yes, exactly.
So what is the point of a planar? That means if it is planar, it can have both sides equal attack only, right? So do I need to really care about optical activity beyond a point here? No. Why? Because I'm going to get a goddamn racemic mixture. Right. Everything which is formed is going to get cancelled out anyway.
Yeah.
Optical activity, you can remember this very important key point. To get a final optically active mixture as product in a reaction must start with at least one optically active substance. It cannot be something which is optically inactive. You cannot start with something which is. Have you learned about this already, or you're not familiar with this point?
No, sir. I was
So
not familiar.
in any reaction where you are going to be having any final product, final mixture as some optically active mixture as the product over there, you absolutely must start with at least something which is optically active in a pure form in the beginning. It cannot be a mixture in the beginning. It cannot be a racemic mixture. You start with a racemic mixture which is optically inactive, you will get a racemic mixture or something which is finally optically inactive.
Okay.
Only when you start with something which is pure will you get something which is optically pure. Or at least you have a chance of that. Sometimes even when you start with something optically pure, you will be getting only something which is optically inactive at the end. Now, let's come back to this here. In any hydrogenation reaction, are you ever going to be having anything optically active in the beginning?
No.
Again.
Yes.
How so?
Wait. Give me 1 second. No, you won't, sir. My bad. You won't. No, you won't.
I won't. Is that sure?
Yeah. No, you can have.
Amount of time now.
Sir?
You took a bit of time to think it through, na? In these cases here, when you're going to be starting with an ene, it can be optically active.
It can be optically active, yeah.
How?
So, I mean, you can have often, like one side you can have, I don't know, it can have a chiral carbon, no?
How so?
How so many?
So basically, some other carbon can be chiral there, basically, right?
That's what I mean, yes.
That's the idea there. Some other random carbon will be chiral in that case there.
Anything in the corner can be, yes.
It's not going to be necessarily this guy, but it'll be some other fellow.
Exactly, yeah. Yes.
So that location, even if it is chiral, if that location is pure, then you'll get a pure optically active compound in the final product there. Think for a second. Let's take a compound like that and discuss it.
Yes, you will. Yes.
Tell me a compound like that.
This, I'll tell the name 1 second. 1, 2, 3, 4. Sir, 4-methyl, 4-ethyl.
4-methyl, 4-ethyl.
Yeah.
You're making it unnecessarily complicated, my kid.
Oh, yeah, no. You can just do that, yes. Yeah.
Right? Make it nice and simple, because the point here was not about this. I want to show you something else over here also. Let's say I'm using deuterium. Okay, if I use deuterium over here, what will I be getting as the product here?
You'll have C, that thing, CD, D, yeah.
Now, have a look at the products. How many chiral carbons are there on that guy?
2, 3, 3. Sorry, 3. 3
chiral carbons, correct?
Yes.
Relax, it's okay.
Yeah.
There is nothing wrong with making mistakes at this stage. The more you feel bad about it, the worse it is. Chill out, it's okay. These are I know what I'm taking here. I know you're going to make a mistake. That's why I picked this. So relax, it's okay.
Yeah.
So in this case here, you're going to be having this guy being formed here, correct? So now let's take this. Let me take that. I'm starting with the racemic mixture. R and S are present over here, both in equal quantity. That is, I'm taking that my starting reactant is in a racemic mixture.
Yes.
What will I be getting as a product there? This will be syn attack.
Syn, yes.
So it can be RR, that is at these two locations. It can be RR and SS obtained as one set of products.
Hmm.
Or it could be RS and SR obtained as the other set of products. Correct?
Yes.
No, I don't see that in your face.
Wait.
Why do I not see that on your face? Why are you not convinced here?
SRRS, how is it possible?
Hmm?
How is SR and RS possible? Should be in the same. Oh, sorry, my bad. Okay. Depends on the, yeah.
So I can see now where your problems are coming. Your problems are with the R and R notation and the S notation itself.
No,
So
no,
first
no.
of all, no, your problems are there. Your problems are there. You've assumed R and S mean something. They mean nothing. They are just
No. What I was
notations.
thinking, I thought since both are deuterium, they'll have same something like
They
that. No,
don't
no,
mean
no.
anything.
So, hmm.
So you will be having RR as a possibility along with the SS. Let's say it's attacking from top. Then you'll get RR, let's say. That means if it attacks from the bottom, you'll get SS.
Okay. Yeah.
And if on top attack, if it is giving you RS instead, then it will be giving you bottom attack SR.
Okay. Understood. Yeah.
So if I had this original fellow as an R and an S both being applicable, then my products formed are R, RR, or S, RR, and R, SS, and S, SS. Correct?
Yes. Yeah.
Have a look here. All of them are formed in equal quantity technically,
Yeah.
because this and this are equally possible. And this,
Hence, these also must be equally.
you're understanding the game here now, correct?
Yes, sir.
So we'll
Yeah.
have these two cancelling, and we'll be having
Oh,
these two cancelling.
understood. Yeah.
So even though we are getting optically active products obtained there, we are going to be getting two sets of racemic mixtures,
Okay.
which means the final
Yeah.
mixture will be optically inactive still.
I see.
Just like how the initial mixture was optically inactive.
So, but you said it could be optically active.
Let's take an optically active and then see. I took a racemic mixture now, correct?
Oh, yeah. You assumed it's a racing mixture. Yeah.
Yeah, I
Yes.
took a racemic mixture there, correct? That's why I had R and S to be equal.
Yes.
Now let's say I'm taking R alone. What will I be getting then?
R and then we get
R milega. And what else?
R, SR. Sorry,
SS.
RSS. Yes.
Correct. I'll be getting these two. Or
Or
I'll get these two.
or RR or RS.
Yes. Or I can get,
RSR.
sorry, not this one. Sorry, my mistake there. Or I can get RS or
RSR.
SR. Now, what is the relationship between these two guys here?
They are enantiomers.
Are they?
No. They are diastereomers.
Good. So these two are diastereomers.
Those two are also diastereomers.
Good. So can these diastereomers cancel each other's optical activity?
No.
No. That means my product mixture now, is it optically active or inactive?
Active.
Correct. So if I start off with an R in the beginning, my product mixture will absolutely be optically active.
I see.
In this case, not always necessarily. So if you want to get an optically active mixture as the product,
Reactant must be optically active.
something in the reactants, I don't care what reactant, something in the reactants must be optically pure.
Yes. Yeah.
Properly optically active.
Correct. Yeah.
You understand the meaning of the sentence? The inverse is not true. If I start with optically pure, I can get optically inactive.
Yes, sir. Yeah.
Samajh raha hai na clearly?
Yes.
Okay. Now, next thing here. Let's come back to the next piece of thing which I want to talk about. Let's go for your synopsis again. So in this here, the entire crap over here is useless. That is all of the stuff which you see here. Let me point it out here. All of this. Most of this. The heat of hydrogenation automatically comes into play from the stability of alkene. So this point is something which is relatively useful. So, but this point doesn't cover everything also. Why does it not cover everything? Because you have not mentioned enough data there. You have mentioned half-ass data there again. What would be nicer to mention here? It will be nicer to mention that more pi bonds broken implies greater heat released.
Yeah, I wrote that.
Where was that?
Right there.
Where, Kana?
Beneath the heat of hydrogenation, number of pi bonds.
Oh, there is number of pi bonds are there. Oh, I thought it was good. Sorry, I didn't notice that properly. My mistake there. So you have written it down properly. My mistake here. You have put it down clearly. Fair enough. So that central bit definitely would be useful. That is this central bit. Yeah, this is something which you can definitely add here. But once you have put this in, the remaining stuff is useless. You understand what I mean by that? That is, most of the remaining stuff is not necessary here. What you have done there is effectively add data which doesn't really add value to you in this particular case here. One second, wait. This is now in a. In this case here, these deuterium reactions, are they really required?
No.
Is this erythro-3O nonsense really required?
No. Nothing.
And all of this stuff over here, which is going to be talking about, all of these changes here. Most of these are not necessary here. Now, this part seems like it is necessary, mainly for the sake of one particular thing. You want to add unnecessary extra detail. You can add it in, but that is what the fuck mosquitoes. Chalo. So you can add it in, but that is not going to be something which is going to be adding value for you at this stage. In the sense, abhi ke liye synopsis dikh raha hai, avoid adding unnecessary extra information like this. You can add it in, but it is going to only complicate the game here. Now, why is it complicating the game? Because you'll have to add in one mechanism point over here to show this thing there. So that is what complicates the situation over here. And that is not necessary now. It is not necessary now. When you're writing synopsis, avoid extra stuff which is going to be adding unnecessary extra layers of complexity. If something is making your thing more simpler and more cleaner to remember and more cleaner to understand, that's good. If something is making your thing more complicated, avoid.
Now, how do I know which one I've actually needed and which are not?
See if it is going to be something which is going to be directly linkable to something extra. In this particular case here, how do you know whether this is going to be meaningful information to add at this stage or not? You have done hydrocarbons questions now, correct? How many questions did you see them using this stuff?
None.
That gives you the answer.
So then where is it useful?
You really want an answer?
It's fine, actually.
No, it's not a wrong question to ask. You have to ask those questions. It's going to be useful because in your internal exams, they will definitely ask that to you.
Okay.
They'll purposely ask that. I'm not against your teacher giving you this year. Ideally, I would have also given. So, this is something which has to be given here because purposely in unnecessary questions, they will give you this. And they are not wrong about it. So you'll have to accept that as well. But it doesn't mean you have to give that information at this stage. You can put that into yourself for a later time. Don't add it in now. So at this stage here, you can technically add it in, but it is not worth it. Skip this kind of information. It is not really going to be that useful. Now, the next bit over here is going to be, actually, no, there is no other next bit. This is basically this reaction completely. Let's go for the next reaction now. So hydroboration reaction. this is something where you have put up unnecessary extra pieces here. But you have also got, I can see that, where is it? Next page for this.
It's right after.
I'm just, don't worry, it's okay. You can see there's an error in the way you have written it. You have scribbled it too fast here and you've got an error here in the hydroboration. The one key thing which matters, you have made an error there.
Wait a minute.
Here.
Oh, the hydrogen.
Yep.
Instead of D, it should be H.
No, instead of H, it should be a D. This part here.
Oh, which one?
This. The purpose of this D is to show that it's coming from that side.
Yes. It should be CH3COD.
Why that happened is because you rushed through this, because you're writing too much information.
Okay.
You only put minimum information, you will avoid errors also. So put only minimum information. In this case here, all of this is superfluous data. All of this is superfluous data. This is also superfluous data, not required. Only thing required was that B2H6, that literally this part here was the key thing there. If this was portrayed cleanly enough, things would have been clean and good to go. And
so
along with that, yes.
In that second example, it should be CH3COD, right?
Correct.
D, okay. Yeah.
Here is a mistake.
Yeah, that's it. Yeah. Got it.
If that is mentioned as CH3COD, then this is fine.
Yeah.
So that's the idea here. So you have to make sure that only the necessary stuff is there. This is useless to you. This is not something you need to consider at this stage. If they ask you questions regarding this kind of nonsense, you can happily skip it and move on, because this is not something which you're expected to remember at this stage here. Next is Woods. Let's look for Woods here. Woods is suitable for preparation of symmetrical alkanes. Okay. Now, very nice. So you put up both mechanisms, free radical and ionic. Okay. All right. Now, in this case here, when you say ionic, is that good? Is that bad? What is happening in this case here? Woods reaction, you have given the entire reaction here, but what can you conclude based on what you have given here?
Free radical will form.
Okay, let me ask you a different question here. You have put both free radical and ionic, correct?
Yeah.
Now, if I ask you a question, which will give me product faster, can you answer? You cannot.
Is there an answer?
Here is insufficient for that.
Oh.
Right? Have a look and tell me. Because free radical, what is more stable there?
Br. Oh, I mean, sorry.
Not that at all. In the free radical mech over here.
Oh, sorry.
In this here, primary is the shittiest.
Yes.
You have basically given the complete worst example for this entire process here. These are the shittiest examples you can give, because your examples are wrong for the free radical. This fellow will never go via free radical. This fellow will only follow the ionic pathway. This is wrong data here. Was your teacher the one who gave you this?
Yeah.
Are you sure he gave you this for free radical?
Yes.
Okay. Free radical will happen for tertiary fellow or secondary fellows usually here, if they give you product. All right. Secondary and tertiary will not give you product properly here. They will go for sometimes elimination reactions and give you alkene instead. So when you're going to be having a secondary or a tertiary type of system, that will go for free radical mech. The reason why I said free radical mech, I think that is not a bad deal, is because not a bad piece of information, is because one of the key interesting things about Woods reaction is the reaction happens for 1 degree, 2 degree, and 3 degree carbons, 3 degree alkyl halides. All right. So the reason why it is happening like that is because If it is only following the ionic mechanism, when you say ionic here, ionic is again not a good term there. Why do I not like the ionic term here? I prefer carbanion. Calling it exactly what it is. A carbon with a
Yes.
negative charge.
Yeah, C minus it form. Yes.
So carbanion, or another way of calling it is organometallic. Because you're going
Yes.
to
Yeah.
be technically having something which is going
At
to be
this.
bonded with the sodium there partially. The
Yes.
carbanion is going to have sodium plus next to it. So carbanion or organometallic here. This means this is electron rich here. Correct? That means what is going to be good for it?
Plus it.
This
Plus
is
B.
electron rich.
Sorry. Minus. I meant minus.
Minus I and
sorry.
minus R will be better for it. What is
Yes,
bad
yes.
for it?
Plus.
Plus I. That means plus I is destabilizing.
Yeah.
Correct. So if the plus I is going to be a destabilizing type of effect, the question became, how does the tertiary give the product? Because in some cases, they noticed tertiary is also doing this reaction. So the question then became, why is it that if this is the mechanism to be followed, how is it that this guy is giving product also? Because if this guy is going to be doing the reaction with this mechanism of carbanion, tertiary should not be forming at all. Or if it forms, it should become an alkene by doing E2 elimination instead. But it forms this product in some cases. So the conclusion was that first you get a free radical in some cases. And sometimes that free radical, if it is stable, it stays as itself. It doesn't go for the carbanion. But in the cases where the free radical cannot form, it will directly go for the carbanion or the organometallic. So in this case here, if you look at the reaction here, the key point to mention here is this. It is going to be predominantly following carbanion or ionic neck. You should have highlighted that there. And you should have made it clear that the first free radical is not something to be followed properly. This is something which I cannot hold against you. So what to say, I will not hold it against you, as I said. Pay attention here. This product over here, your sir has given here. See?
Yeah.
This is the alkene.
Yes.
So that alkene is not going to be a minor product eventually if it follows the carbanion mech. So if this guy follows a carbanion mechanism, which is a tertiary, here it's a primary. Primary, what he is given is correct. This will be the major anyway. Because it does not follow free radical in primary. The free radical, the moment it is formed, it is in the presence of sodium. So it doesn't remain as a free radical. Sodium is like happy thrower. So it throws away electrons like nothing else. So I will eventually immediately have it becoming a carbanion there.
Okay, I see.
So there is no call of calling it as a free radical mechanism at all. It is not a free radical. Think of it like this. The free radical doesn't have octet, correct? So it's a beggar for electrons. How the hell will it stay as a free radical when there is sodium available?
Oh, yeah. So pretty much it's like two steps of the reaction. Like that happens first and then this happens.
You don't need to chuck at all. You can imagine that there is no free radical mech for 1 degree and 2 degree and 0 degree. For those guys, it is only the anion process, the carbanion mech or the ionic mech which you have given here. The problem is
tertiary alkyl halide follows.
When you have a tertiary though, what happens is this particular alkene which is formed here, that guy will become a major system, major product type. If you have a tertiary fellow. So to avoid this, in reality, it doesn't give the alkene alone. It gives this and it gives this also. But tertiary carbanion should not be possible there. So this carbanion should not have been possible for tertiary. So because tertiary gave some of this product, if the tertiary gave only the alkene, there would have been no thought of adding in a free radical mech at all. Remember, everything is hindsight. Scientists see the products obtained, the conditions they are getting it at, and then decide the mechanism.
Okay.
Everything is only hindsight over here. So in this case here, in the case of tertiary, they found that this was obtained certainly, like expected. But they also saw some of this guy being obtained.
So they decided it was also that thing.
They decided this
Yeah.
mechanism then should not be the only thing here.
Oh, okay, I see.
So they realized,
Hmm.
why should this not be the only thing? Because in this case here, for tertiary, the other problem is this C minus going and attacking here. That is tougher. See what I'm pointing.
Hmm.
If this was
Yes.
a tertiary carbon, what happens
Would
there?
that
This
be?
minus here would have been very heavily surrounded by bulky fellows.
Yes.
So if there
100.
are bulky fellows on both of these up and down over here as well, this entire carbon will be very bulky.
Yeah.
And this will also be tertiary then, correct?
Oh, then like so many repulsions are happening. Yes.
Yes. That means there is
Hmm.
no chance of this ever being possible.
Hmm.
Because a bulky location has to go attack another bulky location. No chance.
So that is found. That is found by free radicals.
But this is found.
Oh, okay. Got it. Got it.
But this was found.
So then why don't we
Then
neglect
this was not the explanation.
Then why can't we just neglect that the spherical hindrance has nothing to do with it?
You can't neglect something which is obviously happening.
But then we neglect in other places as well.
What did we neglect here? You tell me.
I mean, a
See,
few
you are
others.
assuming you're neglecting, correct? Your
Yeah.
brain is assuming something has been neglected because you can see it looks like it has been neglected.
Yeah.
Nothing gets neglected ever.
So
Nothing got
then,
neglected.
when we're doing that halogenation,
Mhm.
there's already, suppose we were finding the first question we did, find the number of dichloro substituted, those stuff.
Mhm.
There's already a chlorine there, so why don't we consider hindrance there?
Why don't I consider what?
I mean, it won't want to, like the halogen which is coming won't want to be next to that thing, right?
Perfect. It will be considered. Did we not
Then why
talk about
isn't
that time? Listen, think for a second. What was the second
that's why
part of the question which I asked you then? What did we discuss? We talked about how products on carbon 3 and 4 are not going to be same quantity, na?
yes.
Why? Which is more?
That's why I
4
said
is more
4
than
was
3,
more.
na?
Then I told reverse. Oh, okay. Okay, sorry, I made a mistake. My bad.
You
Sorry, I
understand the
was.
point over here, na?
Hmm.
I called it inductor effect, but there is another way to look at the same thing also.
So
If
then 2 will
all
be very
roads lead
least.
to
I
Rome
know, I
anyway,
know.
I'm not going to show you the other roads which lead to Rome. I will show you the main road to follow to Rome and I'll leave you there. But if there are 2 or 3 main roads going in different directions, in that place, I will tell you don't follow that other road.
Okay, understood.
Here, I had no problem with you thinking the way you thought. Because whatever you think will still give you the correct answer only.
Then I don't know why. Okay. Yeah.
You didn't think in that direction at that time. Because you have not seen it yet. That's all.
No, that's what I was thinking, but then I did. Now that I
You
said
didn't
3
think
for
of it
some
that
reason, I
time
don't know
because
why.
that did not make sense to you at that time. That's okay.
No, but that's what I was thinking. I was thinking about that hindrance only, but I told reverse or something. I don't know
No.
what happened.
You thought steric hindrance, but you did not put common sense there. You thought steric hindrance from the point of view of carbon, cation, carbo, that type of stability type. In
Yeah,
your brain,
that's what I
you
was.
equated it to steric hindrance is greater now, it is more stable.
That's what I was thinking. Yeah.
That was your mistaken point over there. It was not really the steric hindrance part there. You didn't make a mistake with steric hindrance. You are now trying to connect it differently with steric hindrance. That is true.
That's correct. Okay.
Now, let's come back to this here. So this is Wood's reaction. In this here, why is the reactivity happening in this direction? Because in this case here, the halogen has to leave in the first place.
Yes. Leaving a bit.
Halogen, if it is more stable as the -1 charge species, then it is going to be more faster in terms of reacting.
Yes. Yeah.
So carbon iodine bond is easiest to break, and the I- ion is most stable also. So it reacts faster.
Yeah.
That's all. So in this here, you need not have all of these extra points here, but one of your pieces of data is wrong.
The first
That
one.
piece of data you need to definitely make sure gets taken care of, so to say. But
I
otherwise,
can
this
just put like a CH2, CH3, another methyl.
don't add in
Would that
random.
be?
Make a mention, scrap this off to an extent, and what to say, make sure that you add in a point about the fact that this free radical mech applies only to the tertiary case. That is the key thing there.
Hmm.
Make sure you clearly mention that this ionic or carbanion mech is the main mech. All right, that is the main mechanism. That means you will clearly understand 1 degree will go faster here compared to secondary. And 1 degree will also give you better yield of product compared to secondary, compared to
Hmm.
tertiary. But the tertiary will form product. It is not that it will
Yes,
not
sir.
form product. To explain why it is still able to form the product, that is the reason why we have a free radical mech possible.
Okay, yeah.
Do you understand exactly what I was trying to explain here?
Understood, sir. Yes. Yeah.
Okay, now let's go for the next one here. Okay, so in this here, no name reaction, this is going to be silver nitrate, unnecessary. Okay, why does it give this? Yeah, this is not required here. Skip that shit. Next.
Yeah, that's right.
Yeah. Let's not go into the details here. Next, from alkene using hydrazine. Again, skip this crap. Okay. This entire shit is, you will never see this. JE will never use this crap. Skip this shit. This is only for those extra selective questions from MS Chauhan, which you'll be able to answer only with this. So in this entire process here, do not bother about what is going to be happening here. If you want to memorize this reaction, it has to be only one line, nothing more than one line. I'm talking about this using hydrazine here. What should that one line contain? Only this reaction
This.
with a little bit more information about where the two hydrogens are coming from.
Understood. Yeah. Yeah.
Kolb's electrolysis. This is a fairly important reaction. Now, what is happening here? Let's have a look here. What have you put down over here for this? Okay, wood starts at the bottom here. Okay, all right. So mixed woods is something which you can definitely mention also along with the woods. So I will not say that is not needed. That is necessary. This is good. This mixed woods is something which is useful. So yeah, this is cool. Make sure this is there. Kolb's electrolysis. Let's see. I don't see what is mech here properly mentioned. What is the mechanism for Kolb's electrolysis? You put down the mechanism, but you've not put down the key point there. What is the key point which is associated with Kolb's electrolysis? What will be the key point? I don't see the key point here. What is the key point? Dude, are you still on the call? Yeah, you
Yes,
are.
sir.
What's the key point here? Electrolysis, all of that is beautiful and finely written. But that doesn't tell me one very key thing there. What is the point I'm looking for? It's a free radical mech.
Oh, yeah.
I didn't see shit mentioned about free radical mech. You put up all kinds of stories over there, but you've not put up free radical mechanism there.
Oh, yes.
So what does that tell me? That tells me you don't have enough information to answer questions about speed of the reaction, to answer questions about other possible products. You understand what I'm trying to point out over here? You have
Yes, sir.
to make sure you mention just about enough data which will link you up and send you on the correct tangent.
Yeah.
See, every time when you're thinking, there is like a kernel of thought which will lead you down a flow. Your job is now to start understanding that there are going to be these kinds of kernels available of small pieces of thought. You have to start recognizing for a particular flow of data, what is your kernel, and put that down. If you put the full flow, that's not good at all. Why? Because that means you couldn't see anything as a kernel there. That is very bad. That means you didn't understand it at all. You need to put only the pieces which you feel are most critical to you to connect the rest of the pieces, nothing else. If you have lots of other pieces unconnected, that's because you have not understood the game yet fully. There's nothing wrong. Once you understand a little bit more, you will add that data over there. For instance, in that part over there about the hydrogenation reaction, I told you don't need to add that last bit of data there, correct? When will you add the data? When hydrogenation reaction becomes second nature to you, to think of it as the moment I say hydrogenation, your brain immediately goes for syn attack.
Oh, yeah.
If your brain immediately goes for syn attack, then you will know that is going to be connected also. Because the crux behind those points which were given over there, which I told you to omit, was syn attack. Yes or no? Go have a look there.
Yes, sir.
So, if you know the crux point which will lead up to that data, then you don't need that data. But that crux point is going to be a data point for you right now. You do not know that is a crux. So don't try to sense all the different key points over there. Sense what is only key for you now, for your understanding now. Leave it to your future self that fellow will understand it again better. And when he understands it better, he will refine this and put it for you. Have faith in your own self. It's not that, what to say, new. You're someone who does show reasonable amount of faith in yourself. So come, let's go for the next one here. So decarboxylation, Kolb's electrolysis, the key point over there is of course going to be that it follows free radical mech. What does that also mean? That means you're going to be having which one?
Stability.
Yes?
Plus A.
Yes, which means which will go faster?
Tertiary.
Good. So tertiary will do the job better compared to?
Secondary and primary.
Secondary and primary. Good. And if I'm going to be having benzyl, how about that?
Group.
It'll do it even faster, correct? Free radical stability, I'm sure you have learned benzyl is more stable than your teacher, knowing who he is to some extent now. Yes. I'm sure he gave you that key piece of information. Benzyl cation is less stable than tertiary, but benzyl free radical is more stable than tertiary. Given, right?
Yes, sir.
So I expected that to be at least given there. So fair enough. So that is one thing which you can pay attention to. In the Kolb's electrolysis here, the other two parts also are interesting. In the sense, Kolb's electrolysis can actually be used for preparation of alkenes and alkynes also. For instance, look at the example which you have mentioned here. This is for preparing an alkene.
Yes, sir. No. Yes.
So if you already have them bonded between them, you can get an alkene instead.
Yeah.
And if it's a dicarboxylic acid, of course.
Yeah. So in that last example, the bond could form between the two free radicals as well, like this, right?
You can get a double bond also.
Internal, that's right. Oh, how will double bond happen?
You can get a double bond in conjugation.
Oh, wait a minute. Oh, this thing will come this way.
This pi bond in the middle can break, na?
Oh. Then you have two different ones like this.
Yes.
Okay. So it's like the example I wrote in this.
No, I'm not going to go. Don't go there. See, you wanted an answer as to what it will form, so I told you what it will form.
I left this blank. Okay. So, or it could form a bond between the two internal, like.
No. That is too strange.
But it's possible, right?
No, you are not to look at possibilities. You are to look at probabilities. A possibility is different from a probability. A possibility inherently indicates that the probability is extremely low. That's why you're using the word possibility in your brain. Do not look at possibilities when it comes to organic chemistry. You have to look at possibilities also, but not at this stage. When you're learning for the first time, look at probabilities. Which ones are most often possible?
So
Your
then
teacher
here
will ask you to emphasize on possibilities right now, because exceptions will come in the possibilities there.
So then if in a question they was asking how many products will be formed, then what do we do?
You should not consider that as a product.
Okay. So
Why?
here,
That is going to be something which is an extremely strained ring here. You're having a
yeah.
double bond on one side over there already, na?
Yes, sir.
Think of those carbons. They are supposed to be in sp2 hybrid.
But they're in SP.
Are they in sp2?
No, they're not. No.
They are in sp2. Those double bonded carbons.
Oh, they are in SP2, but they're in 90 degree again.
Very impossible.
So
Very much
here, so
impossible.
in which cases does the double bond form into two free radicals? Can it happen anytime?
I can understand what you asked exactly.
So here you said the double bond can break into two free radicals, right? Is that what you? So representing it as like two free radicals on those two carbons.
Not two free radicals. I'm representing the pi bond as two electrons.
Okay, understood. Okay.
You understand now?
Yes, sir. Yeah. Okay.
This is far better than connecting these two pieces.
Yeah.
All right. So this is what will happen. Now, coming back to the next thing here, decarboxylation by soda lime. What did you learn there? Wonderful. This is one of the cleanest synopses I've seen. So you've learned about RDS steps already then?
Yeah, something. Yeah, somewhere.
Somewhat. Okay. Fair enough. I understand somewhat because you've not done chemical kinetics yet.
Yeah, we haven't. So is that a first year topic?
No, Kana. Chemical kinetics is a second year topic only.
Oh.
There's no first year, second year. I do not like the system. So don't.
Yeah.
Your system is second year. I'll give you that much.
Okay. Yeah, that's it.
So in this here, you're going to be having a carb anion mechanism here. Very cleanly I've put up here. Stability of carb anion is going to be what is going to be determining the rate of the reaction. And the rate of decarboxylation is proportional to electron withdrawing groups. Why? Because stability of carb anion depends on electron withdrawing groups.
Yes. I didn't need to write the second part, but yeah.
Yes, we didn't need to write the second part. Only this first part was enough, but you've done a good job over here. This is a very good one here. And one small extra piece of information would have been nice here, which is this R minus, when you're going to be having this particular reaction, this decarboxylation soda lime, it gives you decent amount of yield of product only for preparation of methane and benzene. For most other alkanes, it gives shitty yield.
Using decarboxylation, you cannot form methane, no?
Sorry. In this case, methane, what are we getting here? Methane, naneda.
You can form methane, no?
Yeah, you can form methane. I'm telling methane and benzene are the only ones which will be giving you good yield here.
So, wait. Sodium.
This should be methane, ra.
Okay, yeah, that's right.
So the R should be CH3.
Okay, yeah, my bad. I was thinking something else.
When I said methane, I meant acetic acid. You basically confused it with methanoic acid.
Oh, I was thinking it was formic. Like formic.
Yeah, you thought formic.
Yeah.
Okay. Coming to the point here, you're going to be having only methyl over here. R can be methyl or benzene for good yield. This R here, if it is even something secondary or even primary in some other way, it doesn't give you good yield. This reaction is going to be only useful for preparation of methane and benzene predominantly. For all the others, it gives very shitty yield. We do not use it particularly much. So soda lime, make a clear mention, it particularly works only for 0 degree or maximum 1 degree. Definitely not for secondary, tertiary, none of those. Corey house. This is a beautiful one. So now, this is something where, what to say, there is nothing much which can be done here. You are going to be having this kind of information only. But you have done a good enough job actually for Corey house to an extent, I can see. Wait, let's see. Let me see again carefully. Corey house, you seem to have done a good enough job. You have put in a very good synopsis there. I'm guessing your teacher himself gave it as a synopsis.
Yeah.
Right?
Yeah.
So that's why the synopsis is very crisp and clean here. All of the points which are required are just about correctly given. This is what you need a synopsis to be. You understand the idea here?
Yes, sir.
Now, next, in that synopsis point, there is 1 or 2 pieces of data missing, which can be added in. First, let me take that, copy it off, and tell you the data which would be nicer to have. The data would have been a little bit more useful over here, since teacher has himself anyway given it there. He could have added that extra bit of data. That data would be that in this particular case here, this R, all right, this is going to be similar to C minus.
Okay.
Think of it like similar to C minus. And this location gets attacked. So implies lower steric hindrance matters here. So for this R dash over here, lower steric hindrance is the actual key part. It has nothing to do with anionic formation, nothing of that sort. But for this R here, this is something similar to a carbanion. Implies electron withdrawing groups make it better.
Carbanion because it attached to this 2 metal.
Yes, this fellow comes and attacks this R dash here.
Okay.
Okay, so in this case here, the R here should preferably be something which is capable of forming a reasonably stable carbanion. If it is not good at forming carbanion, there is no chance, or it will be very much more complicated. It will not give you good yield. That means here this tertiary alkyl group here, you have to be careful. It will work, but it doesn't give you good yield for that.
Okay.
And this here should definitely not be tertiary. 0 degree is better than 1 degree here. Because here, as I was saying here, in this R dash part here, only the steric hindrance matters. Predominantly steric hindrance matters. Not only, that is a very wrong term there. Predominantly steric hindrance matters. The electron withdrawing groups will make it better over there also, but steric hindrance plays a slightly more critical role there.
So then why is that PHCH2 thing good?
Where kana?
That the second example in the R dash, yes.
This is going to be something where this is the location. This is what? This is very much free. This is going to be similar to primary, na?
Oh, is it? Okay, yeah, it is.
Right?
Yeah. Yes.
Next, any other piece of data which you find conflicting here? Now, let's go for the next one here. So this part I'm assuming is fine now?
Yes.
Cool?
Yeah.
Okay, now let's go for reduction of alkyl halides. This is something which is going to be a waste of time reaction because you are not expected to understand these reactions properly at this stage. Because simply put, reduction of alkyl halides is something which is going to be a far more complicated reaction. You are not expected to understand it at this stage in any way. So, as you can see here, your teacher has nicely given you a cool little synopsis only. This part, don't bother with it right now. Okay?
Which part?
What I can, this bit here. Don't bother about this too much right now. It is going to be something which will only complicate things a little bit over here for you. Now, in this here, your teacher, I'm not sure what he's given you here. He has given you zinc and HCl. He's given you NaBH4. ये थोड़ा सा problem है. This part I can sense there is something wrong here. This 9th May, there is something wrong here. I do not remember what is wrong here exactly. I will have to think about it and get back to you. My gut feeling tells me it goes like this. LiLH4 can do it for, I think, 1 degree. And NaBH4 can do it for secondary and tertiary, I think. Something is wrong here.
Okay.
I will get back to you on this here. Something seems to be wrong over here. I'll get back to you on this. I'll have to check up some data here. I'll have to do some research for myself as well. My brain is not giving me the correct answer here, but it's telling me there is something issue here. So this part here, don't think too much over here for this. There seems to be something funny here. Next is reduction with HI red phosphorus. Yeah, this is true. This will happen for everything. HI red phosphorus is like destruction. It will destroy anything and everything. And any problems with the HI red phosphorus thing there?
No.
Okay, all right. Now, from Grignard reagent, what did you have in terms of understanding there?
So we're given like 4 lines on it.
So, what you can try to link this Grignard reagent thingy up with is the fact that this is going to be something which is going to be one of the easiest methods.
Yeah, there's a chapter, just
Yes,
a chapter
you'll be
called
learning it
Grignard reagent.
completely separately. There is no problem at all about that.
Hmm.
But the key thing which you need to understand here is this reaction is going to be easily happening. RMGX plus any acid. Water doesn't have to be here. It can be any acid. Water is a very, very weak acid, correct?
Yes, very weak.
Even that guy can do this. So any acid, any substance which you can dream of reacting as an acid will give you the alkene here with this. That is because the RMGX. What is it RMGX similar to?
Anion.
Correct. It is similar to a carb anion. So you can definitely think of it as being similar to a carb anion for sure. Okay.
Wait. Should be a carbocation. Wait.
Think. Who is the fellow who is attached to my carbon there?
A metal and then a halogen.
Halogen. What is the charge that we can take?
Minus.
Minus what?
-1.
-1.
Oh, I see. Okay. Yeah. Good.
What will that metal take?
+1. +2.
+2.
+2. My bad.
It will prefer a +2, right?
R will be -1.
So that's the idea.
So with this information, I don't think I can do those questions, right?
You are not supposed to be able to.
Okay.
So when you say questions, what are you saying exactly?
Like there was a chapter called Grignard's reagent in MS Java.
Yeah, you can't touch.
Okay.
Not right now.
Yeah.
Now, next is Clemenson's reduction. You had your dinner in the meantime, yes?
Some of it, yeah.
Your bowl came, right?
Yeah.
Cool. I just want to confirm that because I didn't want to make you starve and also sleep deprived. That is not fair. You're okay with pushing the class a little bit longer, I suppose, yes? Or you want me to shut up?
A little longer, fine. Yeah.
Cool. Now let's continue. So Clemenson's reduction. So Grignard, I'm assuming you have cleared off with this over here. It's similar to a carb anion.
Yes. Yeah.
Yes.
Yes, sir. Yeah.
Clemenson's reduction. Now, what do you need to know about in Clemenson's reduction? Clemenson's reduction, no need of all of this stuff. You don't need this much information on Clemenson's reduction. Beta elimination. This is alkenes. Okay, reactions is okay. Clemenson.
Isn't the first page I sent you?
Yeah, I know.
Yeah.
So this was your Clemenson's part there. So Clemenson's, your teacher has given you a little bit extra information here, which is not really required as of now. All you need to understand is aldehyde or ketone. okay, can be reduced or converted into alkane directly. So how should you put down the synopsis for the Clemensons here? Whatever your sir has given is acceptable amount in terms of synopsis to an extent. But the problem is you don't need the mechanism. Mechanisms ko nikal do, it is relatively acceptable whatever you have put there. Did you understand what you put down there though?
Not completely. No.
Can you address the points? If you point out the points, I will give you answers for what.
Like the mechanism, I didn't really understand what's happening.
I am not going to touch the mechanism. I told you it's not needed. Other than
But
the
other
mechanism.
than that, yeah, then it's fine.
Oh, really? You understood what acid sensitive groups mean?
I don't know. I don't know what that is. That I didn't understand.
So that's what I was asking, na?
Sorry, I didn't see that point. Yeah, I didn't understand that.
So the idea here is your teacher gave you the mechanism to compensate for that. See, whenever a teacher is basically giving you extra information which is not required at that stage, why would they give it to you? Because they have something to explain which is requiring that extra bit of detail. In this case here, to explain this acid sensitive nonsense, he basically had to do it. So the idea here is when you are having Wolff-Kishner reduction being done, it is something which is done at concentrated acidic condition. So any medium which can react with that acidic medium will not be something which is going to be doing the reaction in the expected manner. It will give unexpected products. So alkenes, alkynes, and alcohols react with acids. Why? Because they are generally electron-rich species. Alkene has a pi bond. Yes or no?
Yes, sir. Yeah, makes sense.
Alkyne also has a pi bond.
Two.
So both of them are electron-rich species. Pi clouds are electron-rich. Similarly, alcohol has an OH group attached to a carbon. That means think of water. Water, if I replace a hydrogen with an alkyl group, the alkyl is a plus I group.
Yes.
That means the oxygen now in the alcohol is more donating.
More negative.
More
Yes.
donating in terms of character compared to water.
Yes.
So it's more electron rich.
Oh, yeah. Yes.
So that's the idea there. Now, Wolff-Kishner reduction, on the other hand, is the same reaction or the same net reaction, but it is done in completely strong basic medium.
Basic KOH.
So in this particular case here, you should avoid anything which can react with the basic medium.
Exact opposite.
These groups as base sensitive groups.
I see. Okay.
So we avoid base sensitive groups in this particular case here. That is what they have mentioned here. Base sensitive, now it should not react with the basic medium. Look at the compounds here. What have they given? Have a look. Carboxylic acid. It will react with the basic medium. Sulfonic acid.
Yes.
Reacts with the basic medium. These are all again groups which will form salt with the basic medium. So halogen again can react with the basic medium. So you need to avoid something which can react with the basic medium. That's the basic purpose here. So when you're going to be having this particular, Wolff-Kishner reduction, this and the Clemenson's reduction are basically going to be doing only one thing for you. Converting the aldehyde or ketone into the alkane.
Alcohol. Alkene. Okay.
Alkane, not alkene. Alkane.
Yes.
But the aldehyde or ketone becomes the alkane in both cases comfortably, but in Wolff-Kishner, it does it in concentrated acidic medium. In the, in the Clemenson's, it does it in
basic medium.
And in Wolff-Kishner, it does it in concentrated basic medium. Means you need to understand that both are meant for different types of compounds with different extra groups present.
Yes.
That's the idea. Yeah. Now, let's continue. Don't give a crap about the mechanism in both cases. Mozingo is again bullshit. Okay? Mozingo is bullshit. You will never get Mozingo. Mozingo is not part of JE. Mozingo is bullshit, which you will see in MS Chauhan. So to make sure that the kids can solve it, sir has given you Mozingo there. That's why Mozingo is like a very clean synopsis already. No confusion in Mozingo, na?
No, sir.
I figured. Carbides. are going to be things which you will learn more about in later topics. Don't worry about them so much right now. Those are not really critical right now. Hydrogen transfer method, that is just bullshit. Don't care about that. So last two, in fact, last three, pranam करके निकल जाओ. Mozingo to रखो थोड़ा सा, it might be useful in some nonsense. Carbides will be useful for later topics. The hydrogen transfer is just. Thank you.
Yeah.
Now, next, let's go for your other parts of the synopsis, the properties of alkanes. So, you've talked about branching, melting point. Okay. There is one point which, okay, you've added that. Nice, but you've not explained it. So, this
Density.
is the. Yes.
The density thing.
Huh?
Which part, sir?
This part.
Oh, yeah, I didn't understand that. No. Yeah.
So, the idea there is melting point la vandu you're going to be having the temperature melting point is actually going to be a transition temperature between a solid and a liquid. Okay. Yeah.
Solid liquid. Yes.
So when you're looking at a solid there, the more efficiently the solid can be packed. The particles of the pieces or the pieces present, if they can be packed in more efficiently, then you're going to be having melting point being more higher. It can remain as a solid for longer, basically. If it is not capable of being packed in properly, melting point will be lower. Now think of a packing here. If the molecule is going to be in a proper shape, which is going to be occupying lesser space, it will get packed better. So what kind of molecules do you think will be ideally undergoing a better form of packing? Molecules are spherical.
Spherical, yes. Yeah.
Right.
Yeah.
Ideally, think if I'm giving you a box, a big
Less
cart,
surface area.
if I'm giving you random objects to pack, what do you ideally want that object to be if you have to pack it as nicely as possible? You make boxes, same shape, effectively you like something which is going to be like
yeah,
which can be packed efficiently.
Yes.
But that's because of the shape of the box there, right? If the box was spherical in shape,
yeah, then you don't space.
Ideally, the scenario here is if you don't have a well-defined space, you'd prefer a sphere. The more spherical the object is, the better it can be packed. So that is effectively what's happening over here also. Melting point, the packing will start mattering a little bit more than the boiling point. In boiling point, what matters is the lesser the branching, the better you're going to be having the boiling point. Why? Because if there is lesser branching, that means the molecule is occupying more space. Right?
Yes.
If it occupies more space, then there is a greater chance for it to interact with its neighbors.
Yeah.
See, if you are lying down on your bench in a very Shavasana type of scenario, more kids around you can poke you or interact with you in some way, correct?
Yeah.
If you're going to be curling up in a ball, well, you protect all your organs and you don't get beaten up properly. Why is that working out? Because you're offering lesser space for contact.
Yeah. Surface area should be minimum.
Surface area is going to be lesser. The exposed area. So that is basically the idea over here. So boiling point is going to be something which will depend on something different than the melting point normally. Slightly different at least. All right. Melting point is going to be something which depends more on the molecule's shape being spherical in nature. The more spherical it is, the better sometimes it is going to be. But this branching part is applicable over there also when you're comparing similar species. If you're comparing completely, large molecules, one which is going to be having more spherical shape, then it will work out in the reverse that this part alone does not seem correct here. This. This and this are correct. This is not perfectly correct. This is fully
For
correct.
isomers.
Yeah, even for isomers. One by branching is not the case there. The more spherical the molecule is going to be eventually, the greater the melting point is going to be. The more closer to a sphere. So if I have something which is a neopentane type of thing, that will
It's like
have
a sphere. Huh.
yes, exactly.
Hmm.
That flow will be having slightly higher compared to its other isomers, which are long chain, melting point wise at least, expected to be.
Okay, understood. Yeah. Oh, okay.
என்னடா ஓ வந்தது? No, seriously. Okay, now let's get to the next thing here. Density of alkanes. Again, nonsense. No requirement to bother with density of alkanes. They're all very tiny. Densities are very tiny. Chemical properties, free radical substitution. This part, you've got whatever you need over here. Plus, 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 plus only. But we have talked about this already. In this here, the energy profile diagram part here. Why do I not need to give a shit about this?
It's implied already. I mean,
everything is implied there. You don't need the energy profile diagram. This reaction depends on the goddamn catalyst.
Yeah.
This is the one which will break the bond which needs to be broken.
Yeah.
Which is my first step. Correct?
Yes, sir.
So the catalyst takes care of the pain in the entire process here. So the remaining things automatically just fall into place. Now, the key things which you need to pay attention to here in this reaction are not exactly this alone. Some other sideways nonsenses here, as you have mentioned here. Pay attention to what I'm pointing here. What am I pointing to here? I'm pointing to the R there, correct?
Dimerization.
Yes. So, in some of these questions here, in free radical reactions, one of the key things which you need to pay attention to is there will be trace products obtained.
Yes, minor products, yeah.
Don't call them minor, they are trace. Minor means they are obtained in reasonable quantity. Wording matters.
Okay.
All right. If I'm going to be having, say, a product obtained as a major product, that means it is obtained at least, like, say, 20-30% yield. All right. Minor product, now at least 5 or 10% of it is obtained. Trace product, now it is obtained in tiny fractions. Like, say, a few molecules out of a few billions. Which will still work out like, say, 0.001% or 0.01% or some shit like that. Those are called trace products. This guy is not a minor product. This guy is a trace product. Am I clear with that? So
why
you
is
can
it like that?
Trace products. What are the other trace products possible here? You can
why is it like that?
You're doing methane plus chlorine, correct?
Yeah. But
you can get ethyl chloride as a minor product. I mean, not minor, as a trace product. Why?
But then why is it trace? Why is it not minor?
Think.
Or major?
This RR has to be producing ethane first.
Yes. Oh, okay.
And then that guy should do halogenation, correct?
It could happen, but is it okay? It's like
it is not about it could happen. I'm not debating whether it could happen or not. I agree it could happen.
Less chance. Yes.
I'm looking at the probability of it happening.
Understand. Yes. Understand.
You understand the idea here? You are only still stressing upon the possibility. Possibility is just the first stage of understanding. The possibility should be converted into a probability eventually.
Okay, understood. Yes.
So you're going to be having those possibilities as trace products over there. Okay, let's move on to the next page now. I would like to at least complete alkanes today.
Yeah.
From the synopsis. Alkenes, when are you planning on writing this?
So I wrote a little bit already, but then it's not too much.
Some parts of reactions, then you went into alkenes directly.
Yeah.
Anyway, reaction with I2. You have mentioned iodination is carried out in the presence of an oxidizing agent.
You gave that point, yeah.
But You mentioned it also here. You mentioned it means your teacher has already discussed that. But
Yeah, he
what
did. Yeah,
you just never connected the pieces properly.
yeah. Yes.
So we have already discussed all of this to an extent now. I suppose you understand how to basically write this better now. None of
Yes, sir.
this crap here,
Yeah.
please.
Mhm.
All right, none of this crap here. Make sure you are making this as efficient as possible in terms of the way you put it down. Nitration. Anything meaningful to discuss there? Absolutely not.
Yeah.
Why? Because it's a
Sulfonation.
reaction. Okay, what is HONO2? Corn nitric acid. Nitric acid is a goddamn extremely powerful oxidizing agent. So, no, this is going to be something which will happen, yes, but you don't need to care about it so much. Same goes for sulfonation. Pyrolysis or cracking is again a bullshit reaction. Isomerization is also a bullshit reaction. These are reactions. Among these here, nitration and sulfonation are complete bullshit reactions from JE point of view also. But
Okay.
pyrolysis, cracking, and isomerization and aromatization, these three are necessary
Later
reactions because
parts.
they are in NCRT.
Okay.
So these three are given in NCRT, so you need to know them. Now, pyrolysis, you don't need to know much. All you need to know is it breaks the shit down. Extreme heat, nothing else to react with, it breaks down. Nothing else.
Okay.
You have, you have a question on pyrolysis, ask it off.
No, nothing. There's nothing to ask. Also. Yeah.
Exactly. There's nothing much to ask. You just heat it in extreme conditions, it breaks down into its pieces, however it can. Next, isomerization is something which is going to be going via a particular mechanism.
Sir, wait. I have a doubt actually in pyrolysis.
Yes.
Could ethine be found?
One second. Which one are you asking on?
The pyrolysis one.
Pyrolysis. Okay.
Yes. Could ethine be found?
Ethine. Possible. 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 Because the ethene fellow, on heating strongly, can break into ethine and hydrogen gas. Possible.
Okay, fine.
Possible. Can happen.
Yeah.
Now, should you bother about it so much?
No.
Correct. Correct. That is the other point which I wanted to make sure you understood as well. You don't need to give a shit about whether you really get ethine here. Because pyrolysis as a question is never going to ever get asked. Why? Because it is something which is like a flat fact-based reaction, which is useful from a JEE main standpoint, provided they are asking the exact same details in the NCERT textbook, which I'm sure you will definitely swallow by the end. Now, coming to isomerization. The key point to remember in isomerization is usually in this isomerization reaction, you use a strong Lewis acid. AlCl3 is what is called as a Lewis acid. Okay, you are familiar with what a Lewis acid is? Yes?
Yes, sir. Yeah.
So, this AlCl3 is a very strong Lewis acid, and we specifically use that guy over here. What can that tell you here? What does it tell you? When there is an acid.
This acts as a base.
This is an acid. Correct?
So this carbon thing is a base.
Good. What will happen to the carbon thing then usually? What do you think might happen? If it's a base, logically I told you, what is the name I called this? AlCl3. I called it what type of acid?
Lewis acid.
Good. What does Lewis acid do?
Second. Donates electron pair.
Reverse.
Oh, sorry. It takes, my bad. No, yeah.
It accepts electrons. Whereas the Lewis base or whatever is going to be behaving in somewhere or another as a base will end up forcibly giving electrons. Correct? So if this bugger, the compound over here, somehow or other gives some electrons.
So, but what electron transfer is happening here?
Don't think about what happens. Stop thinking too much. Stop thinking about the product. Think about the nature. So if this fellow gives electrons in some way or another, the final product formed should be some, or the middle filler formed will be something which is not having enough electrons.
Hmm.
So
Carbanion.
what would be
Carbocation.
the possible mechanism flow here,
Free radical.
or
Ionic.
ionic?
Okay.
Ionic. Is there
Carbocation.
any ionic? Stop calling shit ionic.
Carbocation.
Carbocation. I do not want to hear this shitty word ionic ever again. All right,
Okay.
that's a very shitty generic word which just messes up the things over there. No ionic. I don't want to hear ionic anymore. Your teacher might give it. Don't follow ionic. Call it what it has to be. Is it a carbocation? Is it a carbon free radical? Is it a carbanion? Is it an organometallic? These are your 4 things.
Okay.
The carbanion and organometallic, your teacher seems to like to use ionic there.
Yeah.
So in this case here, it is not ionic for sure in that sense, but it is going to be carbocation predominantly. All right,
Yes.
that is where you are able to get these weird isomeric properties over there.
Oh, hydrogen shift, methyl shift, all that happens.
Oh, you have done shifting of carbocations?
Yes.
That's why. Exactly. That's what's happening.
Okay, that makes sense.
All right, so you get a carbocation in the interim there that will do rearrangements, and that rearrangement results in your isomerization actually happening.
Okay.
Now, next, heat of combustion. Yeah.
Similar to the heat of hydrogenation, I guess.
Fairly straightforward there, nothing complicated there. Correct? But why? Why is combustion exothermic in nature?
Because we need to. Oh, sorry. Wait. Bond break. Endomixo. Bond is making.
Bond is breaking. Bond is forming. But why is it exothermic?
1 second.
How should you proceed for a question like this?
Sir,
I told you in organic you should start putting shit to paper.
Yes, sir. Because I think this forming will require more energy because C double bond O bond is stronger than is very strong. So you need to provide energy. Huh?
Why is that very strong? Let's take a simple equation and talk.
Yeah, I don't know that.
You know that. You're just not thinking about it. So let's put down the reaction. This is the reaction.
Yeah.
Let's look at the bonds breaking.
CH bonds, 4 CH bonds.
Good.
2 O double bond O bonds.
Wonderful.
2 C double bond O bonds are formed.
And
then 4 OH bonds are formed.
Beautiful. Now,
CH is pretty weak. O double bond O is
exothermic. CH is pretty weak. CH is fairly strong.
Oh.
It's not fucking weak. It's very strong. That's why you need something as reactive as a halogen atom to go react. In your entire homologous alkanes are not reactive. How often does your Vaseline react with your mouth? Go on.
Yeah. So here you can compare the CH and OH.
Good.
Because equal number. OH is stronger. So you have to form because it's electronegative. So it's pulling the hydrogen.
So
it requires more energy to form. Oh, wait. No, it doesn't. Polar covalent.
Polar covalent is generally stronger than covalent. Ionic are generally traditionally stronger than covalent.
Correct, yes.
All right, because there is more direct attraction. So same way, based on that, the polar covalent bonds are generally going to be stronger. The exact same reasons you gave, but you have to tell it as polar covalency.
Okay.
Next.
Yes, sir.
How about here? Same crap.
Same reason? Yeah.
Same crap. Right? So the idea here is the product bonds are far more stable than the reactant bonds.
Stable versus yes.
Why? Because the product bonds are more polar.
Chemical bonding, yeah.
Chemical bonding, exactly.
Yes.
Organic chemistry completely links up with every other part of chemistry to a great extent, and within itself tremendously. So
Yeah.
you have to start expecting that there are going to be connections everywhere. So this is why all your combustion reactions are exothermic in nature. And literally speaking, enthalpy of combustion or the amount
Negative.
of energy released during combustion, which is generally written like this, is going to be greater if you have more fuel.
Hmm.
More shit
Indeed.
burning, more products are formed, more energy is released.
Correct. Yeah.
And if you're looking from calorific value point of view,
Hmm.
how do you check that? More hydrogen percentage, more enthalpy, more calorific, more per gram. Why?
Okay.
Why? Because when you look at calorific value, that is going to be the heat of combustion divided by molecular mass.
Oh, molecular.
All right.
Yeah.
And hydrogen is inevitably the best fuel because it's the lightest fuel available.
Oh,
So
okay.
it always provides more bang for buck, more bang per gram. Think of it like that. All right. So in this case here, the carbon, if the percentage is higher, it will release lesser technical, amount of energy per gram. Per
So then
gram.
why don't we use hydrogen to power like most of our stuff?
If we were in a planet where we had plentiful hydrogen, yes, we probably would. And we are using hydrogen to power most of our stuff. It's called solar. The sun goddamn
Oh.
uses hydrogen only, na.
Oh, I mean that's okay. Yeah.
We just don't see it.
That's, hmm.
And the reason why we do not use hydrogen on Earth too much is because we don't have hydrogen in pure form on Earth. Not in that quantity. Not naturally available. Now,
What do you mean not naturally available?
where do you see hydrogen on Earth?
In the air.
Huh? In the air. You see it in the air. I thought you see it
I
inside.
mean,
Hmm? Where do you see hydrogen on planet Earth?
you don't.
No, we do. We see it here in my hand.
Water.
Yes. Right?
Yeah.
So hydrogen on planet Earth is in combined form.
Oh. Okay.
Predominantly as water.
Okay. I see. Hmm.
So you don't have hydrogen in pure form in practical amounts in Earth. You'll probably have it in some thermal vent in some volcano somewhere, but nobody gives a crap about that.
Yeah. Okay.
Now, next was what? So heat of combustion is fine. This part is fine. What is this? What do you put over here, Raf? What is this part here?
Wait. Oxidation reaction.
Oxidation reaction. Okay. So among the oxidation reactions here, only one thing matters. Which guy is that which matters? Where is it came in?
Oxygen.
This guy. This statement
Oh.
matters. Because that is in NCRT.
Okay.
That is this reaction. This bottommost. You can see that one?
Yes, sir. Yeah.
That bottommost alone matters. The remaining is hogwash. We don't need to care. Okay, the remaining is hogwash. We don't need to care. This though matters. This is there in NCRT. You need to know that reaction. That is tertiary carbon with a hydrogen available will get oxidized by KMnO4 to the corresponding alcohol stage, and it will stop there. So you definitely need to know that part there. Okay. So this is okay. So we have discussed the first page. We have had a look at the second page. Third also I've had a look. Fourth I've had a look. Fifth was which one here? This was decarboxylation. Had a look here. Okay. This one beta. This is the reactions of preparation of alkenes, right?
Yes.
So we'll go to that also, but we'll finish up the remaining here.
No, sir. That's
preparation of
it.
alkenes. All the pages are same preparation of alkenes only. They all go into alkenes.
The rest of this is all these elimination reactions,
Okay. So these are your preparation of alkenes, your short notes from your classes stuff, correct?
Yes, sir. Oh no, sir. This is still a part of alkenes.
He's given it under reactions, yeah.
Yeah. I mean, he put it between alkenes and alkenes, not like under the name alkene.
No, this is the part which is necessary to understand those. These are
Alkenes.
preparations of alkenes only. This is not supposed to be coming anywhere else.
Oh, okay.
He's discussed it over there. So, hmm. Seriously, he's mentioned all this crap over here.
Yeah.
Your teacher has been an asshole, Muthu. I've lost a little bit of respect for him. Disappointing. Is there that much pressure on your teacher now? Is he some new fellow, somebody who is basically trying to prove his place in the campus or something?
No, no, nothing like that. As far as I know.
Yeah, okay. He knows his shit. I will not deny that, but a little disappointed with how he is given shit here. What are you supposed to understand by Seitzev and Hoffman's man here?
Something
You understood anything at all?
somewhat.
Okay, we'll have a look at. He's even given LDA here.
Yeah.
Okay, so I'm not going to go here. I'll get more and more angry if I see that thing. Not worth it right now. And it's way past where I need to shut up as well. What is your situation like tomorrow? Till when are you on holiday?
Tomorrow.
Tomorrow is your last day of holiday?
Yeah.
Day after you have office? Gee, school?
Yes, sir. Yeah.
Sorry, to work for you anyway. It's all the same. So, we are all slaves to the goddamn system. Our own. um, your teacher is going to be running, is what I can see. Unnecessarily cramping it and running. Consolidate alkanes. It's okay. We'll go patiently. We will catch up when we have to catch up. What is your teacher going to be going into in school next?
We'll continue alkenes.
And after that?
I think alkenes. I'm
No, other
guessing
than
alkenes.
organic, you told me something else. He'll be
Oh,
going.
I guess we have to start thermodynamics.
Oh, damn it. Okay. Chalo, miserable only. Thermodynamics
So,
will be easier for you.
huh.
So, but yeah, it depends on how much he's rushing and how.
So
Yes.
we also had our face test.
When is your face test, Kana?
No, it's already done.
Already done.
Yeah.
So I remember now it was supposed to be that day. Yes. How miserable was it? How comfortable was it?
Chemistry did not go that well.
I
But
remember we had discussed that it was never going to go well.
yeah.
And seeing what your teacher has given you, it should not have gone well. He's only teaching for like 3 or 4 students in the fucking class there. Right?
Yeah.
How do kids understand the stuff directly, fully in your class?
Like three. Yeah. 3 of them. One of them's a ninth grader.
One of them is in
He should be in ninth grade. One of them.
ninth grade now?
He should be in ninth grade. He skipped 2 grades to be with us.
A kid.
Yeah, he's 2009 born, and he understands it.
He understands it?
Yeah, very well.
Yeah. Fair enough. I'm not going to go into these things right now. That is not my game here. But yeah, tell me more about your face exam. I remember asking you to do only one thing there: mentally prepare yourself and not
Skip.
overcompensate there.
Hmm.
Did you achieve that?
I lost a few questions. I lost, I think, 2 questions when I attempted for alkenes.
And
I guessed a few right. Also, I mean,
I
but
remember discussing no guessing, na.
yes, sir.
Um,
I mean, I remembered slightly,
or
so
when
that's
you
why
say guess, you meant you remembered it and then
somewhat.
you. Ah, okay, that is fair
I
enough.
wasn't too sure, but I put it just. I don't know why.
Hmm. And can you send me the question paper
Yes, sir.
and tell me how much you scored?
Score is in. Okay.
How much did you score on them on these papers? How did your physics and maths go?
Physics was kind of bad, sir. As I told, we rushed through the entire thermodynamics and all, and mainly those
Yeah, that
most
was
of
also
came.
horrible. Chalo, go on. Maths
In
was
math,
better or something, na?
in the question paper my teacher made, I did not too good, but the second paper I did fine. Actually, in the
And,
first paper, I could have done very well. I could have done better, but I made many mistakes again, so it was gone.
how was your point of view of the chemistry papers in both the papers? Could you have done better? Could you have improved upon your performance?
Yes, yeah. I messed up a few questions I would know.
And why did you mess up and what type of questions did you mess up?
It's a counting question. I समझ.
Okay, all right.
So,
So
but
this
surprisingly, a lot of questions came on these alkanes and alkenes.
alkenes in the area on the lots, is it?
No, alkanes mainly, but alkenes not too many.
Alkanes, a lot of questions.
Yeah.
That is the reason why your teacher rushed through that, no?
Hmm.
He expected that only.
Yes.
So practically the entire class bombed.
Few did okay. Few did fine.
And why did they do fine?
I mean, their chemistry kind of saved them.
No, you're not understanding my question. I wanted to know. Let's have a look. Let me have a look at the paper. First question you should be having able to answer. This is
Should
definitely
have.
doable. Hmm?
No, what did you say?
The first question, 19th, is doable. You got marks on this or not?
No, sir.
You have to check why you were not able to do it. Now, tautomerism, what did you learn? What is the necessary condition for tautomerism? How did you learn it as?
Uh, alpha carbon must have sp hydrogen. Sorry,
Alpha
sp3.
or alpha carbon should have a hydrogen or alpha location in conjugation effectively should have a hydrogen. So you got
Exactly.
this
Yeah.
20
Yes.
correct or not?
Yeah, I got it.
Okay, good enough. 21, you will not have probably been able to do it at this stage.
I left it.
Good, good leave. 22, alcoholic KOH, major product. This is again something which you are not going to be able to do properly here,
I
mainly
got
because
this.
you would have gotten this correct probably because the only option possible over here is that, right?
Stability. I just checked. Yeah.
So common sense led you there.
Yeah.
But that is not the ideal path to approach this type of a question here. So
Yes,
this
sir.
is going to be something where you should have been a little bit more careful about how to basically place your options over here. This is a
Hmm.
very tricky question. You would have gotten this correct, but you got it correct by luck, not by
Okay.
much else. Degree of unsaturation. This is something you should have gotten correct.
Yeah, I got it, sir.
This is your normal aromatization reaction from your NCRT.
Hmm.
Okay, they've given that same thing again over here. Wonderful thing.
Yeah,
Okay.
that's kind of lucky.
How about this one? You got this one correct, 24 correct?
Yes, sir. Yeah.
Good. Okay. 25. Doable, certainly.
Yeah. Hmm.
Correct or not?
Yes, sir.
Okay.
This one, I guessed. I guessed and I got passing marks.
Yeah, this is an easy question only. There's nothing complicated there. So
Yes, I think
carbon-carbon bond formation.
I knew that Wirtz and Colby's were correct, but I wasn't sure about the other two.
Think for a second. Corey Housler, is it forming or not?
It is. Yeah.
How about Sabatier syndrome?
No, no, it's not. It's breaking there.
Yes, no. Why? Because it's only breaking a pi bond there.
Exactly. Yeah.
So that is
I knew
definitely.
that B was wrong. I wasn't sure about C. So I.
Fair enough. 27. This, the moment you see this, you would have left this.
No, no. I attempted.
You should have left it. You got
No,
this
I
correct?
know. I got it wrong, but I know
Yep,
what mistake
yep,
I
yep,
made.
yep, yep, yep. Stop talking. You have seen enough MS Chauhan now to recognize when there is like big fat molecules, there are going to be twists happening.
SIPSIR.
You have learned that much by now?
Yes, sir.
And you have also learned enough never to trust your goddamn instincts when it comes to unnecessarily unknown data. This is the type of typical question which you should have chucked. Now, yeah, I'm not going to rechange that point there. You should have not touched this. Which options did you lose on over here?
This. Sir, I wasn't sure which one was pyridine, which one was pyrrole.
Then why the
I-
fuck did you attempt this?
I don't know.
Now this
I
is
mean,
an no. Let me finish. This is an error, not in terms of the answer or the question, in terms of judgment. Bad error in terms of judgment. When it comes to more than one answer correct question, what did I would have given you a hint on what you should use now as your what to say benchmark to touch the more than one answer correct question.
if you know, like, yeah.
If you know for almost all of the options, if there's partial marking, you see there's partial marking here,
Yes,
but
sir.
there's negative marking also, now.
Yes,
Why
sir.
would you attempt an option where you don't know shit about? Right? And in
Yeah.
this case here, they have purposely made it in such a way that you have to pick for all of the options. You can't choose one. So this is something where it is going to be a much more trickier question than the remaining. You should have skipped this. Next, how about 28? This you
I
could have
got
got.
partial marks.
You got this?
Partial mark, yeah.
Partial marking. I'm guessing you did not go for the option C.
No, C I put. Actually, yeah, C I didn't put, my bad, yeah. Actually, wait. I don't remember whether I put it or not. But I
But
was
you got
thinking.
marks on this.
I got partial marks, yeah.
29.
Yeah, I
You
got.
could have attempted it. This I'm sure your teacher has discussed in your class.
Yes, yes, yes. Yeah.
30.
I didn't want to risk it, so I only put A.
This is an easy question, Kana.
I was like, definitely it's A, B, D, or A, so I didn't want to risk it and put it.
This is an easy question.
Yeah.
Monobromo derivatives formed by alkanes with formula is or are. So monobromo derivatives, A is fine, B is fine, Delhi is going to be wrong.
C is directly wrong. It only has 4 carbons. So.
Yep. So we're not going to look at C.
I was confused over the
Why
isomers
is
will be
Delhi
formed or
wrong?
not. Delhi, it's wrong.
Why?
Is it wrong?
Is it wrong? It is wrong. A monobromo derivatives formed by the alkanes. Okay, they're just asking is or are. Okay, huh? Delhi is technically correct then here. I took it as major products over there. Major products, Delhi would not be there. Why would it not be there in major products?
Because it's not stabilized.
No, they would have gotten it in the other location. This location would have been major.
That's what I mean. Yeah. Bromine would attack the tertiary.
So if you are looking at only whether it can be formed, yes, it can be formed. I didn't read the question properly. They are asking only whether it can be formed. So yes, ABD are fine over here.
So isomers would also be able to form.
Sorry?
Isomers would also be able to form. Would also form.
Isomers, not good. I do not understand what you're meaning.
Oh, sorry, sir. I don't know. Sorry, my bad. Nothing. I understood the question now.
Oh, okay. All right. 31.
Yeah, what could have easily gotten on that? Okay. 31 I left.
You have gotten 30th, definitely.
Yeah, I don't know what I was thinking. Yeah.
31.
I left it. Sir.
Why?
I wasn't sure.
Yeah, I can see Kolb's is there and soda line. That is enough to confuse you.
Yeah.
But this is an easy question. With your synopsis available now, you should be able to get this 31 done.
Yeah. Sir, also, what is rainy Ni nickel?
It is just a form of
Nickel.
where it is going to be in very nicely finely powdered form.
Okay.
So the surface area for the nickel is maximum.
Okay.
Okay. How about 32? That would have
I
been
got partial mark. Partial mark.
Which one did you get?
A and B.
Okay, fair enough. So, effectively speaking, you did not really lose so many marks. You just did not gain so many
Yeah.
in this paper. Is that correct?
In that paper, yeah.
So, how much did you score in chemistry in this paper?
31 out of 66.
That is not a bad score, huh?
Sir, but paper 2 kind of
How much was the general population score in this paper?
30s.
So you did not do that 40s, huh?
No, 30s.
So you did reasonably well in this paper then.
Yeah, average was like 30s, yeah.
So you basically did reasonably well here compared to what your circumstances are. You have done quite decently well here. So the other paper is the key thing then.
Yeah, I don't have the PDF for the other one.
Fair enough. Send it to me some
Not-
other time. I'm going to close it today now.
Okay, sir, yeah.
I'll see you later. Are you sure you're okay with continuing on?
Huh, sir?
What is
Wait,
your
I
sleep
found it, sir.
normally, huh?
It's fine, I can sleep. I sent you the second paper, sir.
Okay, so you want to discuss that for sure then. Chalo.
I mean, I got the questions cleared out. I just want to show.
No. It's not about the questions. The problem is not really the questions or the answers for you. Nah? The problem is why you do them.
Yeah,
The second paper.
yeah. The solutions are there.
Answer notes for them, huh?
Yeah,
Okay.
I don't have the exact.
No, it's okay. It's okay. I will manage with this. Is not a problem. Find the number of compounds that are more acidic than benzoic acid. Okay, this is a question where they have purposely given formic acid. Formic acid, did you know about that?
Yeah. Yes, sir, I knew.
We knew about formic and oxalic.
Yes. Oxalic, I didn't know, but
If you know formic, you know oxalic. No, oxalic is stronger than formic after all.
yeah, that's what I assumed and I got. But
So you got this correct?
yes, sir. Yeah.
Okay. Degree of unsaturation. This is a cheap question. But I'm guessing you didn't count shit properly.
The C triple bond and I didn't. Oh,
So you didn't count shit properly, correct?
yeah.
Why? Can you tell me why? Because you don't have the habit of putting pen to paper. The first thing you should have done the moment you saw this was exactly what your teacher has done. Look at what he's done. What's he done?
Draw the full diagram.
He sat and put pen to paper and drew the goddamn full diagram. This is your first step. You don't have that ingrained in you. You have to get it ingrained in you. Next, how many of them can exhibit resonance? Fairly straightforward.
Yeah.
You got this correct or wrong?
Yes, sir. Correct, sir.
Okay. How many secondary amines are possible with the formula? You got this wrong?
Yes, sir.
Which one did you miss up on? Or you counted one of them twice?
No, I missed up on two of them.
That is actually quite bad.
Yeah, that's right.
Which ones did you miss? You'll have to check out. We'll have to talk about this sometime else. Among the following, the number of aromatic compounds is or are. What happened here?
Oh, this one. Oh, I wasn't sure about that. That one. The second to last one.
Oh, second to last one.
Yeah.
Really? You're not sure of this?
No,
This
I
looks
didn't
like a
know.
goddamn benzene ring to me.
I know, but then I thought the other double bond also had some role in it.
So if I'm going to be having a molecule which is going to be having one part of it being aromatic and the other part is remainder of the molecule is a long chain, is that a non-aromatic molecule or is it considered as aromatic?
It's aromatic.
Then why the hell did you have any other thoughts here?
I didn't come to my mind during the exam.
Hopefully that will come to your mind from next time onwards. Did it come to your
Yes,
mind after the exam at least, or
After exam, yeah.
Please tell me you got this correct. You forgot about the double bond here.
Yeah.
Beautiful. So effectively, this paper is just slightly a more trickier version of that one.
Yeah.
How much did you score in this?
21 or 66.
And what was the average in this?
30s again.
30 seconds. We'll
Oh,
talk
in
about
the
this
paper.
next episode. I have to go now because I have to go piss. Been drinking a lot of water. And
So the previous paper was a 62, by the way. My bad.
62 mark paper.
Sorry, 61. 61. Yeah.
Doesn't matter, man. 60, 61, 62.
Yeah.
I
I
don't.
was just.
I'm looking
My
at how
bad.
much
Yeah.
you approximately got, whether you were in parity or not. So in the second paper, predominantly you bombed it to a great extent.
Yeah.
And what would be your rank in the class in the first paper in chemistry?
Somewhere in the middle, like maybe 15, 10, 10 to 15. Something.
10 to 15 in the class.
Yeah.
That is not a bad performance at all, bro. I'm actually quite impressed. I expected your batch is what, 30 something, no?
37. Yeah. 36.
And consistently you have been where in organic till now?
Bottom
20,
15.
25 to 30, no?
25 to 30 years. 20 years to
So
30s.
not bad. This is a decent performance then. Not bad at all. And the first paper was okay. Second paper, what was your rank like?
Pretty low. Like,
How
again,
much?
25s.
25?
Yeah.
So you just went back to your original position there. That's all. Nothing really remarkably bad there.
Yeah.
You are just blaming yourself more than normal, I suppose.
Yeah. Somewhat.
Okay, not a problem. So it's not that bad of a performance then. And I can see you have actually started putting in serious effort. Are you liking solving questions yet?
So, I mean, starting doing the question is kind of difficult, but once I start doing it, it's okay.
You're getting comfortable with it. You're liking the flow there.
Yeah, but then I need to get that flow started first of all. That's
There's nothing which you can do about that, Ra. That initial friction is going to be there. You know how static friction is always going to be greater than rolling friction.
yes,
So
sir.
that
Yeah.
applies everywhere. That's
Hmm.
not something which you can beat. So, all right. I really have to go. I will see you some other day. I think I should officially at least inform you if I'm considering it. I am not sure how long I'll be taking classes for.
Okay.
I am seeing that it is getting tighter on my timing right now. I will take for at least this month and for sure. Maybe for one more month till your organic gets comfortable. I'm not sure after that.
Oh,
So when I say I'm not sure after that, I don't mean that I'm going to be cutting interactions off. It will be non-paid interactions, and I won't keep time. You understand what I mean by that?
yes, sir.
More critically, I got pissed off with this female irritating me a little bit unnecessarily. But don't worry about it. That is not on you. So, if I do end up stopping, I'll give you reasonable amount of notice. Think of what to say. This is not a notice. This is not a notice of any sort. I will give you more notice, but it might happen within the next 1 month or 1.5 months. So I'll probably inform Himatej also, so that if it does happen, we will see how we can go forward. Maybe I might. Problem is this: I'm not able to get like at a stretch where I can discuss like a reasonable amount of topic. It's like it's getting today's session was relatively productive. We could at least clear off alkanes fully.
Yes.
And if we can get like more sessions where like more consolidated work can be done, that is better. because chemistry like, you are able to benefit properly only when like stuff is completed there, and then you are basically doing like a second round of refinement over here.
Exactly. Yeah.
And
Yeah.
if that is not there, refinement is meaningless there. And if I'm not benefiting you, I know I'm not benefiting me so much. So anyway, so it's because I'm being very honest here. Organically, you're learning things for the first time. So your questions are very basic. So it's not exactly that interesting. But at the same time, it is important for you to get this cleared off properly, because I can see you're making wrong connections. I don't like that part. And I want you to start realizing that to make the correct connections, you need to start accepting that, yeah, my brain is now not having enough data. Let me actively prevent myself from making the connections now, because it is going to be only wrong as of now. And you're a sharp kid, dude. I like you and your way of working. So let's see how long this goes on for. But just information that there is a good chance that I might drop out in a month or two. So make maximum utilization of me whenever you see me from here on out. I will also try to be as productive as possible with you, because I do not want to. You're a sincere kid. I can see even on Pongal holidays you're working so much. I'm quite happy. I'm quite impressed by that actually. So, are you okay though, mentally speaking?
Yeah. It's fine. Yeah.
That's the problem. I can see it is only it's fine every time. So,
Yeah.
all right. See you then, dude. Bye bye.
Yes,
Have
sir.
a good night.
Good answer. Yeah. Thank you.
And I'm quite impressed, honestly. Your performance is not bad.
Yeah.
I'm
Thank you,
actually
sir.
quite impressed. Your performance in the first paper is quite good, and your second paper performance is not bad. It is still on par. You've just taken a few liberties because you felt you could, I feel. And the paper came out a little bit trickier. So it's okay. I will have a look at the second paper as well. I don't know what exactly has gone down. But first paper, what according to what you told me, you could have gotten at least another 2 more questions correct.
I think 40 would have been possible. No.
I did not feel 40 is possible. I felt like 32, 33 was possible.
I got 31.
Oh, sorry, you got 31. Then 40 was possible. Yeah, sorry. I felt like another 8 to 10 marks more would have been possible. Sorry. Second paper was 21. Correct. Yeah.
Yeah. Yes, sir.
So, yeah, 40, you could have touched 40.
A
If
little
you were
lucky
close to
inside
40, what
side.
would your rank have been in the class?
Oh, that top 7 maybe. 5. Yeah.
So, you were there nearly. Just by eliminating your indecisiveness and what to say, eliminating out the problem areas, you are almost there. You just have to consciously do it a little bit more and accept that you are going to be knocked once in a while. The second paper was a knock.
Yeah.
Your job is not to get defeatist about it, because defeatism is not going to help you now. So, yeah, you could have been a little bit more positive about the fact that your phase exam was completed. You need not have sounded like phase exam ho gaya, mera war laga diya. So physics went that bad.
Physics is pretty bad.
Okay, I figured. I mean, if chemistry has not gone that badly and you still sounded like someone who has been stabbed and kicked in the wrong places.
Yeah.
So somewhere you got kicked in the wrong place for sure.
Yeah.
Okay, all right. Bye-bye. Good night. Have a nice
Thank you,
night.
sir. Good night, sir. Yeah. Bye.
When can we have the next session? That we'll see later.